everyone. I welcome you all to the live session on Apache Spark Scala full course by Intellipaat. This session is conducted by multiple experts who will be teaching you everything about Spark and Scala from basics to advanced level. Before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Apache Spark. In that, we will tell you what is Spark and why do we need it. Then later on, we will learn about Spark components and architecture of Apache Spark. Then later on, we will learn about Hadoop ecosystem. Post that, we will be learning about Scala and also we will tell you how to install Scala. Post that, we will learn about types of variables in Scala. Then later on, we will learn about static class and also do a hands-on demo to give you a better understanding of the subject. So guys, this is the agenda of the video. Without any further delay, let's get started.
So the first thing that you need to understand is Spark is comparatively a newcomer in the big data world. When you say newcomer, see Hadoop came in 2005, and then if you look at the other projects like Hive or Pig or HBase, they all came somewhere in 2007 or 2008, etc. Spark was developed in 2010. So if you look at the history of Spark, Spark was created in 2010, 2009 or 2010, you can say, at University of Berkeley. So Spark was created as a research project. So a group of researchers at the University of Berkeley, they had a project called AMP Lab project. The project is still there, and they were just trying to create uh, a distributed processing engine, and thus they created Spark. And you also have to remember that in 2010, MapReduce was the popular big data processing engine, right? Because MapReduce came in 2005 and it was, very popular at that point in time. So when Spark was created, one of the, what you say, goal was to create a big data execution engine, which is probably better than MapReduce. So if you really ask me where Spark fits in our Hadoop world, I would say that it actually sort of like replaces MapReduce. Even though Spark can do much more than that, but if somebody asks you like, okay, on Hadoop, where do we see Spark? Or when you compare Hadoop and Spark, where do you see it? My answer will be Spark is an execution engine very similar to MapReduce and probably better than MapReduce. So I will see Spark probably as a replacement for MapReduce, right? As a better execution engine. But like I said, that's not the complete story. Spark can do many more things, and we will get into that eventually. So, in 2010, when Spark was created, it was kind of like a university project. And like I said, it was an execution engine, big data execution engine. Very soon, people found that Spark is much, much faster than MapReduce. So then what happened? The Spark project was contributed to Apache. It became an open source project. I think somewhere in 2012 or 13, it became part of Apache open source project. But again, I think it took couple of more years. People started using Spark in the industry by around 2015 or 16. This is my personal experience. As far as I know, it became popular somewhere around 2016 16, I would say, or 15, which means it is comparatively new, right? Because Hadoop came in 2005, and it was popular. But Spark is like in 2016. But from there onwards, it was a roller coaster ride. As of now, Spark is the most contributed and most widely used big data open source execution engine. So Spark holds many records actually. At one point in time, it has the highest ever number of committers in Apache open source projects. And today, even if you look at the industry, there is no big data project without Spark. So it's probably the most widely used big data project. Uh, Around 70 percentage of workloads uh, in around the globe, if you look at big data workloads, are handled only by Spark. So it's probably the most popular open source project right now when it comes to big data, right? Spark is specifically designed for big data. You cannot use it for other kind of case studies. In the sense, the real advantage of using Spark is if you have huge amount of data. Like if you want to process maybe 1 GB of data, probably Spark is not the right choice. You can have other execution engines as well, right? So that is a brief history of Spark, but then the real question that people usually ask is, why should I use Spark? And this is a question that probably people need answer to. Like, yeah, Spark is probably the most used project, but why should I do it? Why should I go for it? So obviously, it's a big data processing engine. So naturally, you can think about all the use cases where big data is involved. I'm quite sure that you have gone through many case studies and all in big data, and you were probably learning that using MapReduce. So wherever you find a big data problem and MapReduce as a solution, you can replace that with Spark. Spark will fit anywhere. But what are some of the other unique features of Spark? So if I go to the website of Spark, the first thing is, let's go to the official website of Spark, which is nothing but spark.apache.org. So you can make a note of this website because this website provides the up-to-date information, also a very nice documentation related to Spark. So the site is spark.apache.org. This is the website. And by the way, I almost forgot the original founders of Spark. Um, there are people like Mate Zaharia, Bill Chambers, the people who created Spark, right? These people, they went ahead and started a company called Databricks. So Databricks is the company which is created by the original founders of Spark. And Databricks basically sells Spark. So you can just go to Databricks and ask for Spark. Um, they have a proprietary platform. It's not open source. Okay. Also, they don't sell only Spark. It's kind of like a platform, but Spark is the what you say brain or heart or whatever of their platform. And Databricks is the leader in the industry when it comes to Spark because these are the people who created Spark, right? So we will be using the Databricks platform for some of our hands-on. So Databricks provides a free platform for practicing Spark. Uh, you may not be able to do everything there, like all the hands-on, but some of the hands-on, we will switch to the Databricks platform and experience it there. Okay. Um, Now, when you go to the official website of Spark, you can see the definition. It says Apache Spark is a unified analytics engine for large scale data processing. Yeah, that's the definition. We'll come to the definition. And the advantages are already written in the website. First thing you see here is speed. So Spark can run your workloads 100 times faster. 100 times faster means what? In comparison with MapReduce. So this is not always true. I mean, these are what you say benchmark numbers. There were cases where they took a benchmark and Spark ran 100 times faster than MapReduce. That's true, right? But don't think like in the industry, every time you're running Spark, it's going to be like 100 times faster than MapReduce. But yeah, it's fairly faster than MapReduce. I mean, you cannot compare them. On an average, my experience is if a MapReduce program takes, say, 1 hour, Spark will do it in 2 to 3 minutes, probably, maybe in seconds. So it's like nowhere near to Spark. So speed is definitely uh, one of the what you say advantages of using Spark, and how Spark programs are faster. So Spark does something called in-memory execution. So in-memory execution basically means, when you read the data, you keep all the data in memory. In memory means in the RAM. So as long as you're processing the data, the whole data is kept in the RAM or the main memory, and only the final result will be written back to the hard disk. When you go to MapReduce, this is different because in MapReduce, you have a mapper, then reducer. So after the mapper phase, what you say, whatever um, output is there, the intermediate output is going to be written to the hard disk. So for a map reduce, it uses the intermediate output. It will write and then read. So it is kind of like slower. But when it comes to Spark, it is faster. So speed is definitely one of the advantages. Second thing is ease of use. Write applications quickly in Java, Scala, Python, R, and SQL. So um, if you talk about the programming languages supported by Spark, these are the ones: Java, Scala, Python, R. Now, among them, we are using Scala because Spark itself is written in Scala. It's one of the most widely used language when it comes to Spark. There are a lot of companies, for example, JP Morgan Chase, right? They use Spark with Java. The reason for that is more or less the developers or the workforce. So if you're working in a company and let's say you have a lot of Java developers, then it makes sense to, how do I say, go to Spark and then develop programs using Java, right? And especially if you are a person coming from machine learning, data science, deep learning, you're probably going to use Python or R. So for machine learning people, Python or R are their primary languages. So Spark supports that also. However, it does not really matter which language you are using. If you write a Spark program in Scala or Java or Python, it will run exactly the same. There is no difference, right? It just depends on what background you're coming from and which languages you are comfortable. Spark also supports SQL, so SQL, right? And SQL is probably most widely used with Spark now. So you can use Scala or Java and Python. However, more than them, Spark SQL is the library which is being used a lot. And we will get eventually there, and I will talk about what is Spark SQL, and all these languages and all. So ease of use in the sense you just need to learn one language, maybe like Scala, and you can work with Spark, or maybe Scala or SQL, any of this, right? Now, the next thing that I want to talk about is something called runs everywhere. And this is, I think, a question that many people have. So people may be wondering, hey, where can I run Spark? I mean, where do I install Spark, right? Spark is practically platform independent. You can install it wherever you want. All you need is a cluster. So one popular option is you can run Spark on Hadoop. And this is a widely used option. So you can take Hadoop, install Spark on top of Hadoop, and then Spark can run on top of Hadoop. And one thing you need to understand is Spark doesn't come with storage. And many people have this confusion, right? There is no storage for Spark. Spark is like MapReduce. Does MapReduce have storage? No. MapReduce is just the processing engine, right? Very similar to that, Spark is just a processing engine. All Spark says is, okay, you store the data wherever you want, give me the data, I will process it. So when you say you are running Spark on Hadoop, um, HDFS will be the primary storage on Hadoop. Yarn will be your cluster manager. Spark will be the execution engine. You can also run Spark on top of something called Mesos. Mesos is another cluster manager like Yarn. So what I can do, I can take a bunch of machines and maybe I don't want to install Hadoop. Okay, so I can take a bunch of machines, install Mesos on top of them. So Mesos becomes like Yarn, your cluster manager. Then install Spark on top of that. In fact, the original Spark came on Mesos. You can also install on top of Kubernetes. This is, how do I say, container orchestration, microservices, and all. So, if you are aware of technologies like Dockers and containers and all, Spark very well works on top of that. Or in the cloud, so many of the cloud vendors like Amazon or Azure have their own implementation of Spark. You can go to them, they will set up Spark on a cluster and allow you to use it. Or there is a mode called standalone. Standalone mode basically means you install Spark uh, on a bunch of machines, and Spark will come with its own cluster manager. So what I'm trying to tell you here is, let me take a pen thing so I can talk about it. Yeah, so what I'm trying to tell you is Spark requires two things. One is storage and one is resource management. So if you're installing on top of Hadoop, what happens? You will get HDFS. This is the storage, correct? On top of that, you will get what? Yarn. Yarn is your cluster manager. On top of that, you install what? Spark. This is one option, and this is very common because many companies might already have a Hadoop cluster and they probably want to install Spark. So this is your storage, right? And this is your cluster manager, and this is Spark. The second option is you take a bunch of machines. So here I will just say machines, and let them be your local storage. You bring up this cluster manager, which is called Mesos, and then you install Spark. on top of that. Third option, again, you take a bunch of machines, and there is something called Spark Standalone. And then you install Spark on top of this. So what I'm trying to tell you is all these are same. There is absolutely no difference in terms of execution, I'm saying. So Spark just says it needs to be installed somewhere. So you need to provide storage, a cluster manager, for Spark to work. So one option will be I go to Hadoop. So their HDFS is my storage. Yarn is the cluster manager. Or I take a bunch of machines, create a cluster, and use something called Mesos. Mesos is another cluster manager. Or I take a bunch of machines and use something called Spark Standalone. Spark standalone is where Spark will come with its own cluster manager. You are not using Mesos or Yarn or anything. Spark will have a Spark master, its own cluster manager, and gets installed in the cluster. So all three options are equally good. It's not like one is better, one is bad, or it's just your use case. That's all, right? So these are the common options you have. On top of this, you can install Spark on Spark in the cloud, as well as on top of Kubernetes and many other options, right? The other point I want to clarify is once you install Spark, so let's say you have installed Spark. One of the speciality of Spark is that it can read and write data from almost any platform. And this is, in fact, I think a great feature when you talk about the big data requirements and all. Because normally, when you look at the big data requirements, one challenge is okay, you might have data, but the data may be in different places. So Spark is capable of reading the data from, let's say, any RDBMS platform. So this can be Oracle, MySQL, Microsoft SQL, any of this. Or if your data is on top of any data warehouse. So this is like Teradata, Greenplum, Netezza, any of these data warehouses. If your data is there, Spark can read. Or you have your data on top of any NoSQL database. For example, your data might be on MongoDB, Cassandra, DynamoDB, Spark can read it. Or the data might be in any of the cloud stores, Amazon, Microsoft, Google, uh, any of these cloud, right? Or it can be even in other systems. For example, Spark can read from SAP. There is an SAP connector. Spark can read from mainframe. There is a connector. Spark can read from, if I remember correct, it can also read from Salesforce. There is a connector. Spark can also connect with almost all the BI tools. So, for example, Tableau, Informatica, Spotfire. So you see, this tool is not what we are thinking, right? Look at the connectivity options. You are saying that you can connect to almost any platform. I have listed almost everything that I know. RDBMS, data warehouse, NoSQL, cloud, SAP, business intelligence, ETL. Almost any tool you bring in, Spark will be able to read and write the data. Accordingly, Spark is being used as an ETL tool now. So there are many organizations who use Spark as an ETL tool, and an excellent one, because the challenges will be even in the big data world, you have your data lying in many different platforms. You might want to read and aggregate them, clean them, and write it into some other platform. For example, I might have data in MongoDB. I might also have data in Salesforce. I don't know. So I want to read this, combine them, write it back to, let's say, Oracle. Spark can be used. So one of the use cases of Spark is uh, connecting to a variety of data sources and bringing the data and then transforming the data. And I will show you an example of how Spark can be used as an ETL tool in our course, right? So this is another great feature of Spark. So what did we discuss? Coming back to the discussion. So I was telling you why somebody should use Spark. Why somebody should use Spark? The speed. So definitely it is faster, and the ease of use, like you can use one language and then do anything, runs everywhere. So you can bring it up on any platform, doesn't matter. Also, it allows you to read and write from any type of data source. If this is not enough, right? See, the classic problem with Hadoop is, so we always try to compare Hadoop and Spark, but the classic problem with Hadoop is if I go to Google and search for Hadoop ecosystem tools, let's say go to here. So have a look at this picture. So this picture talks about Hadoop ecosystem, or this picture talks about what is Hadoop and uh, what are the tools you can install on top of Hadoop. So as you can see, Hadoop has HDFS, then Yarn and MapReduce. Fine. So this is, oops. So this is basically the core of Hadoop. Like you have HDFS, then you have MapReduce. Now the point is when Hadoop initially came, okay, it was supposed to be a batch processing platform. Even if you look at the definition of Hadoop, you will see that Hadoop is a batch processing engine. So all Hadoop does is, okay, it takes a bunch of data and do batch processing. Now, again, for this, what happened? A lot of tools were created. So, if you look at Pig was created so that map reduce programs can be written easily. Okay, so there is a engine called Pig, right? Then some folks said, okay, Hadoop is great, but we want to do SQL on top of Hadoop. Okay, and that is how this tool called Hive was created. So Hive is basically what? SQL on top of Hadoop. Some other guy said, okay, you know what, everything is fine, but we want to use machine learning on Hadoop. So for machine learning, Mahout was invented. Then some other folks said, okay, we want tools to ingest the data. Then Scoop and Flume were invented. So the problem is this Hadoop ecosystem is ever growing. So for each type of analysis, you have one tool. For SQL, people use, let's say, Hive. For machine learning, they use Mahout. For batch processing, they use Pig. So I have to learn like, I don't know, 5, 6 different tools when I want to work with Hadoop. The advantage of Spark is when you come to Spark, this is the Spark libraries we have. You just download Spark and install it. And whatever Hadoop and all these 6 different tools were able to do, Spark alone can do it for you. So Spark comes with built-in libraries. For example, if you are interested in just batch processing, okay, you are a developer, you just want to read some big data and do some batch processing, you use something called Spark Core. So this is basically what you call, this part is what you call Spark Core. Okay. Spark Core is basically the execution engine. And here you get this abstraction called RDD. I was talking about RDD, right? So one of the ways in which you can program in Spark is using this Spark Core and then RDDs. So what you're doing here is you're going to Spark and you're saying that, okay, I just want to do batch processing. That's all. and I am a developer. So Spark will allow you to directly interact with your core library.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD. B. Data frame. C. Data set. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
On the other hand, you say that, okay, I'm a SQL developer, then you go to Spark SQL. So Spark SQL is where you are using your SQL library. So you can create tables, write SQL queries, do join operations, just like whatever you are familiar with SQL. If you want to do real-time data analysis, you go to Spark Streaming. So Spark Streaming is where you have real-time data analysis. And this is something I guess people might not have seen. So normally in the Hadoop world also, all the tools are created to do batch processing. There is no real-time processing. Spark provides you with a library called Spark Streaming, which can do real-time analysis. And I will explain what it is later. Now, if you want to do machine learning, there is a library called, MLlib. So MLlib is the library which allows you to do machine learning. There is even a library to do graph processing. So the real deal with Spark is it is not only faster, it is not only easy to work with, it is not only something which you can install everywhere and read from everywhere, it comes with a bunch of libraries to address any kind of workload. So in the modern day big data projects, our problem is really this, and Spark solves it. The problem in modern day projects is that I'll give you an example from my experience. Imagine you are designing a system which is going to catch credit card fraud. So credit card fraud is a very common thing, right? So, what happens? A lot of people steal the credit card, they will hack and, they do fraud, identity theft. So maybe you have a credit card, somebody will steal the number, the CVV code, then they start using it. So credit card fraud is very common. And what happens is, if I want to design a system which can catch, let's say, credit card fraud, what are the challenges? So my first challenge is this system should be real time. Real time in the sense, millions of people might be swiping their credit cards, right, during peak hours, and you want to catch it and then probably make a decision, right? So if I am getting all the credit card transactions today, if I analyze it next month, it is going to be useless because uh, this is fraud and you have to do it in real time. So I need a system which can process, say, 1 million transactions in a second and make a decision. So you can use Spark, and there is Spark streaming. Then in the credit card fraud system, I also want to implement machine learning because usually when there is some sort of a prediction, like whether it is fraud or not, machine learning is heavily involved. So again, you can use MLlib in Spark. And in the credit card, what you say, fraud detection system, I probably want to use SQL, so I can use Spark SQL. So you see, using the same Spark, you are able to implement three-way approach actually. This is not possible in Hadoop. When you go to Hadoop, the problem is for SQL, you have to install Hive. For machine learning, you need to install Mahout. For real-time processing, you need to install something called Storm. And integrating all these tools together is a challenge. But in the world of Spark, like I said, um, it comes with all these built-in libraries, so you will be able to perform uh, all these kind of analysis using a single tool. And that is the real advantage of using Spark. Um, I'll get back to your questions in a moment. Also, I think probably I spoke about it, but if you look at the versions in Spark, right, Spark has three major versions. There is something called Spark 1, or the 1 dot release, we call it. Nobody uses 1 dot release, it's pretty old. Then you have something called Spark 2 dot release. 2 dot release is what people use in the industry uh, as of now. There is also Spark 3 dot. Some of the customers started using it, but it is comparatively new. We will be using Spark version 2.3.1 in our course. So now I can quickly, refresh the slides to talk about these things, right? This is exactly the same thing that I was talking about. So if I go here, yeah, uh, this is again the same Spark architecture we were talking about. As you can see, on top, you can see the languages, Scala, Java, Python, R. Then you can see the libraries, Spark SQL, Spark Streaming, MLlib, and graphics, right? At the bottom, you have Spark Core. And like I said, it can read from all these platforms. So you have many platforms actually listed here. You have like Cassandra, HBase, MySQL. And I almost forgot one more thing. Okay, so I almost forgot one more thing, which is Spark is also capable of reading any file format. And I will show you an example for this. Uh, File formats are very important. So you might be aware of CSV, JSON, XML. So Spark can read all of this. On top of this, there are some big data file formats. We have ORC, Parquet, Avro. Spark will be capable of reading any of these file formats, right? And convert them from one format to another one as well. So then what we spoke about. So this is again the categories of Spark components. Again, same thing I was talking about. The programming languages you can see, the libraries you can see, but end of the day, the execution will be handled by Spark core engine. Then cluster manager can be Yarn, Mesos, or Spark scheduler or Spark standalone. Storage can be HDFS, standalone machine, cloud or RDBMS, even NoSQL. Um, so one more thing you need to understand is the data need not be always with Spark. For example, you might have installed Spark on top of Hadoop, but that does not mean like you have to keep all the data in Hadoop. Yeah, it can read from Hadoop, but the data may be, some of the data may be in Cassandra, some of the data may be in cloud. Still, Spark can read and process it. So, like I said, it's a processing engine rather than something like Hadoop. Okay. Yeah. So, what we have to understand now is something called Spark architecture. So we will build on the Spark architecture. I mean, we will understand the basics, and then, you know, we will build on that knowledge, what it is. Uh, See, usually what happens is I might have to use my pen. So usually what happens is when you create a Spark program and then submit the program, you definitely need resources to run the program. And I think this is something everybody agree, right? So you may be processing a 10 GB file, or maybe you're processing 100 GB file, or you may be processing data from different sources at the same time. So whatever you do, one thing is sure, you need resources to run the program. So one way to get this is from the yarn. Not one way, the only way. So who will give you resources? Resources will be given to you by the cluster manager. Let's say yarn. So we are assuming that Spark is running on top of Hadoop. So if that is the case, the cluster manager is yarn, and yarn is supposed to give you all the resources to run the job, right? And what happens in case of Spark, the resources are given to you in the form of something called executor. That is what you see in the picture. So there is something called executor. What is an executor? Uh, in Spark's terminology, executor is a combination of CPU and RAM. That's it. It is like a container given to you so that you can run the program. An executor is a combination of CPU and then RAM. So you can go to Yarn and ask for as many executors as you want. Also, you can decide what is going to be the configuration of the executor, like how much RAM, how much CPU cores, all you need. And this has to happen depending on the data that you are handling, right? So depending on the data and the complexity of the program, that you're written, you can probably ask uh, for this. So typically the executors are allocated uh, um, based on the decision of Yarn. Now, this is actually a very crucial thing, but in my experience, you will not be the only person who will make this decision, right? Because let's say you created a program and you want to run the program in a cluster. Now, you may be reporting to somebody, or maybe someone else will also be responsible for running this program, right? So you are probably not the only one who thinks, okay, I can run the program. uh, Now executors can be launched on each of the machine. So if you have 100 data nodes or 50 data nodes, on each of them, executor can be launched. And there is a calculation that typically you use. To show that calculation, we need a cluster. So I'm just going to use a cluster that I know. Don't worry about this. So there is something called CloudX Lab. So I'm just going to log on to this lab so we can see what the resource policies are in this cluster. Let's try to log in. So the executors are allocated by yarn. So you need to go to yarn. Okay. You go to yarn and you will be able to see some of these options here. I don't know where to find it. Let me just check in this cluster. So if I go to yarn, non-manager, if I go to configuration, yes. So, see, first thing you need to understand is if you go to what you say, yarn, you can find these requirements. There is something called memory node. Memory allocated for all yarn containers on a node. So there will be restrictions. Okay. So in this cluster, what you see is memory allocated for all yarn containers on a node is 9 GB. So you can see this value. This value is 9 GB. So maximum 9 GB is in this cluster. In the real world, it might be bigger. Okay. In this cluster, maximum RAM that can be allocated for an executor is 9 GB. Minimum is, okay, so that is for all yarn containers on a node, right? And then there is a minimum container size and maximum container size. So you can set it individually. So minimum is 128, maximum is actually 5 GB, right? So all containers put together, it should not cross 9 GB total. For an individual container,
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
right, minimum 128, maximum 5 GB is the size. So let's take these things in account so I can write it. So on a machine, uh, maximum memory of all executors put together in this cluster I'm talking about, okay? Executors is 9 GB. Minimum memory for one executor is 128 MB as per this cluster. Maximum memory for one executor, that is 5 GB as per this cluster. Okay, you also have settings for CPU. So if you scroll down, this is CPU. So you can see minimum container size is 1, maximum container size is 8. So for CPU, what they say is minimum CPU for one executor is 1. Maximum CPU for one executor equal to 8. Okay, so these are the settings. This is set by your administrator. That is why I'm showing this page. See, this is the yarn page of this cluster. So you can see the total RAM for all the executors together is 9 GB. Minimum RAM is 128, maximum is 5 GB. And minimum CPU core you can ask is 1 core, maximum is 8 core. So you need to first understand this, then only you can ask for resources. Now this may change for different clusters, and these are very small numbers because this is a training cluster. In the real world, this might be in gigabytes and very big numbers, but you need to understand this. And now if you come to this picture, what you do is typically when you are creating a Spark program, you create a Spark program, and within the program, you will be able to set all these numbers. I will show you how that can be done. But typically, when you write a Spark program, within the Spark program, you will be able to ask resources to run the program. And when you launch a Spark program, what is going to happen is, take my pen, there is something called driver program. You can see this blue box. The driver program will start on one of the machines. So I'm just assuming this is my data node 1. So remember we discussed about driver program even in Scala. What is the driver program? The driver program contains settings to run the program. So this can be, for example, the resources you are asking, the compression that you are using. All this is part of the driver program. So typically what happens is the driver program will initialize on one of the machine, and it is going to create an object called Spark context. So Spark context is basically an object. Okay, it is an object, and this will be initialized by the driver program. Now, why do you need this object? Because once this object is initialized, you can see using this object, the driver program will talk to your cluster manager. The cluster manager in this case is, let's say, Yarn. So driver program starts first. It will initialize the Spark context object. Using that object, it will connect your cluster manager Yarn, and then The driver program will negotiate resources from yarn. So in this simple example, you can see there are two executors. So the driver program is going to yarn, will go to yarn and say that, hey, you know what? I need two executors. And you will also say that, let's say each executor, let it have 8 GB of RAM and 8 CPU. As an example, I'm giving. So each executor, you are assuming you have like 8 GB of RAM and 8 CPU. So the driver program will go to Yarn and say that, hey, Yarn, uh, in this program, the developer has asked for two executors, each with 8 GB RAM, 8 CPU. So Yarn, what it is going to do, it will launch these executors. Now, you really don't have any control here. If there are no resources, right? So suppose sometimes what happens, your cluster may not have enough RAM. Then what will happen? Yarn will not launch any resource for you. Your program will wait in the queue. Nothing will happen. But assume you are in the ideal environment where there are resources in the cluster. What Yarn will do? Yarn is going to launch two executors. Now, again, there is no control as to where these executors will be launched. Yarn can even launch both the executors on one machine. Quite possible. That depends on the discretion of Yarn. But let's assume that in this ideal example, Yarn launches one executor on each of the data nodes. So this is my data node 2, okay? And this is my data node 3. These are three data nodes in the cluster. So Yarn launches one executor on data node 2, one executor on data node 3, and each executor has 8 GB RAM, 8 CPU cores and all. And now your driver program will push the business logic in the form of something called task. So if you're wondering what is this task, when we write the program, I will show you. But if you write a Spark program, it will be broken down into smaller pieces of unit called task, which can be executed. So the driver program, now since it has got the resources, it starts pushing these tasks to the executors and they execute it parallelly. Once the program execution is over, the final result will be sent back to the driver program. So driver program is the one which will be getting the final result or output or whatever you call. So driver program gets the final output, right? And then the executors will be deleted. Executors are only required at runtime. You don't need them like all the time. They are only required at runtime. Once your processing job is over, executors are also deleted. Now the question will be, how do I know how many executors I need? Well, there is no hard and fast answer to this. Okay, so next question will be, okay, I got the idea. You're saying that to analyze the data, you will ask for executors. But how do you know that you need two executors? Or better, how do you know that each executor need 8 GB RAM? Like, what is the logic that you're using here? Well, the logic is something that probably has to come with experience. To give you an idea, if you have a 50 GB file, let's say you have a 50 GB file to process, I can ask for even a single executor with 50 GB RAM, but that is probably not a good idea. So as an example, what I'm going to do, I will launch 5 executors. This is just an example. Okay. 1, 2, 3, 4, and 5. So this is my executor 1, executor 2, executor 3, 4, and 5. So I'm going to launch 5 executors in this example. Each executor gets, let's say, 10 GB RAM. So each are going to get 10 GB RAM. Also, each executor will be getting 10 CPU cores, assume. So I'm just going to say 10 CPU core. This executor, 10 CPU core. Again here 10 CPU, 10 CPU, 10 CPU. So I have requested for 5 executors, each with 10 GB RAM and 10 CPU core. Now the problem is how this 50 GB file will be loaded in 5 separate machines or 5 executors. So Spark uses a concept called partitioning. Spark has a concept called partitioning. Partitioning is nothing but dividing your data. That's all. So when you are reading this file, 50 GB file, you can ask how many partitions you need on this file. So I'm going to say that, okay, I want to divide this file, this 50 GB file, into 50 partitions. So when you say 50 partitions, each partition will be like 1 GB. Okay. And then what is going to happen? Partition 1, then partition 2, partition 3, up to partition 10 will be loaded here. Again, partition 11, partition 12, partition 13, up to partition 20 will be loaded here. Partition 41, partition 42, all the way till partition 50 will be loaded here. That is how the processing will happen. So I think I spoke about too many things at one time, and maybe people are kind of like confused probably. So I will reiterate what I'm trying to explain. So first thing is, how do you decide the number of executors? Now there is no hard and fast number, like I said. In this example, I'm calling for 5 executors to fit 50 GB data. So rough figure will be, if you have 5 executors with 10 GB RAM, you fit 50 GB data. You can also ask for 10 executors with 5 GB RAM, right? That also works. But normally the rule is the number of executors should not be too less or too more, what you call, right? See, if the number of executors are very less, like you're calling for 1 executor, then only 1 machine will be participating in the processing and it will be very difficult to process the data. If the number of executors are more, for example, for this 50 GB file, I can call for 50 executors. Absolutely possible. But if I call 50 executors, the problem is there will be a lot of data shuffle operation. Sometimes, say you are using Spark and you do a join operation, the data might have to travel from one executor to another executor. So if you have too many executors, that will be a problem. So I came up with a number 5. Okay, that is my golden number probably. Each executor get 10 GB RAM. So 50 GB can be accommodated there. Now the most important point here is processor. Processor. Why processor is important? First of all, processing has to happen, right? Data needs to be processed. So you need CPU. The second reason is CPUs are not easily available, meaning I can have a server with 200 GB RAM. I cannot have a server with 200 CPU. Check it out. I don't think it is possible. CPUs are limited. Okay, so when you plan your processing, you should consider CPU. It's not possible to process your data if you have only RAM. RAM cannot do processing. So that is why in this example, for each executor, I have allocated like 10 CPUs, 10 CPU core. So now the rule is you have 10 CPU core, and ideally each processor core can process some data. That is where partitioning comes into picture. So this 50 GB file, when you're loading in these executors, you can partition them.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and data frame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
And I will show you how to do this practically, but you can basically run a command and the file will be split or partition. So I decide 50 partitions so that each CPU core in an executor get one partition to process. That is ideally how you should design. So when you have a processor core or a CPU core, it has to work with one partition. And there is no golden rule as to what is the size of a partition, but 1 GB is something typically we can consider. Even it can process 2 GB or 4 GB, but in this simple example, this is what we do. Now, you don't have to break your head some ground rules, and also you don't decide this on your own. You cannot go to your company and say that, okay, I learned Spark, I'm the boss, I'm deciding partition. You will be fired the next thing. So you need to take permission from people to do all this, because this all affect the cluster, right? So yeah, your theory might be correct, but you need to, discuss this with other people, maybe your administrator. You ask your administrator, hey, I have 50 GB data, I'm going to launch 5 executors, will it work? He will say, no, it's not going to work, increase it to 7. Some reason, right? So you need to adjust all this, but end of the day, the total RAM uh, among all the executors should fit your data, and the CPU cores should process each partition. That's kind of like the rule. Okay, I'm bored with theory, let's go to hands-on. Since we spoke so much, I thought I will do something. I will show you what. Okay, let's open the Intellipaat VM. I'm just going to open this Intellipaat VM. But I want to show you a couple of things before we get into the actual hands-on kind of thing. So I'm starting the Intellipaat VM, and I am connecting with the VM. Intellipaat VM. And in order to work with Spark, there are many ways. If you want to write a Spark program, you can always use an IDE like Eclipse we have seen. So you will be able to develop your Spark program using an IDE. I will show you that. But more than that, Spark also provides us with an interactive shell. So if you want to work with Spark using Scala, all you need to do is just type this command spark-shell and hit enter. So this command spark-shell, this is going to launch something called Spark Interactive Shell using Scala as the language. So once we get the Spark shell, we will be able to type the code and execute it and see and all. So as you can see, when I type Spark shell, you can see the Spark version is, okay, it's 230, not 231. That's okay. So you see Spark has started, version is 230, and you can see the Scala interpreter. So basically, Spark has started, and I'm using this Scala language to write programs on top of Spark. So one thing I wanted to show you today was that you can just type spark hyphen shell, and then you get an interactive shell for Spark. Um, and also you see something here, it will be written Spark context web UI available at this location. So whenever you start the Spark shell, Spark also gives you a web UI. It will be available in 4040 port number. I can just copy this, go to my browser, paste it, and there you go. So this is the Spark UI. And as of now, you don't see anything in the Spark UI because, typically when you run any program or any logic, then only Spark UI will display something. As of now, the UI is completely empty. We are not going to run a program, right? And I can exit from here. Now, if you are a Python developer, there is something called PySpark. So PySpark is where you will be working with Spark using Python. So in order to get the PySpark shell, you can just type PySpark. So I'm going to just type PySpark, hit enter. And what happens here is again the Spark shell will be started. But now you can see again Spark came, but you don't have Scala here. You have Python. So now are you able to understand the connection between Spark and the languages? Spark is the execution framework, and you can program in Spark using any language. So this is your PySpark. So I just typed PySpark and this started. And now I will be able to type Python commands here. They will be executed by Spark if I want to do that. Well, I think we will not be using PySpark. So I will exit here. Let me start this uh, Scala shell once again because I want to show you one more thing. So we will be working with this command called spark-shell because this will bring the Spark interactive shell in Scala. And this is where we will be spending most of our times. And I want to show you one more thing. So when I start Spark, it says that the web UI is available in 4040. You can see that the version is 2.3.0. It also says Spark context available as SC. What is this Spark context? Go back to the diagram. So Spark context is this object using that your driver program is communicating with the cluster manager. So normally when you start this Spark shell, the Spark context will be automatically created for you. So you can see Spark context available as SC. SC is the name of the Spark context object. Also, you see something interesting. It says master equal to local. What is this? There is something called local mode in Spark. What is local mode? In local mode, Spark will run only on one machine inside a single executor. So driver, executor, everything is going to be inside a single machine, single JVM. That is local mode. Why? This is good for learning, development, testing, and all. Local mode is great if you want to experiment with Spark. See, if you want to learn Spark, you don't need 100 node cluster, right? Spark will behave exactly whether you are running it on one machine or 100 machines. So by default, when you start Spark, you see it is starting in what? This local mode. Now you can do everything in Spark using local mode, but the difference here is, like I said, it is using our Intellipaat VM. Intellipaat VM is one machine. So you are not actually getting a cluster. But I wanted to show you a cluster as well. What I'm going to do, I'm going to use Google Cloud. Well, any cloud platform will do. But if you go to Google Cloud, okay, I have an account with Google Cloud. You don't have to do this, don't worry. If you go to Google Cloud, they allow you to quickly launch a Spark cluster. It's very nice. I'll show you. So you can go to Google Cloud. There is a service called Dataproc here. I go to this service called Dataproc and I can ask Google Cloud to give me a Spark cluster, Hadoop and Spark cluster. How? So it says here, Google Cloud Dataproc lets you provision Apache Hadoop clusters and connect to underlying data stores. It will come with Hadoop and Spark. So I can just say create a cluster. Okay. And I can give a name for my cluster, not required right now. And cluster type is like one master and n worker, meaning you will have one master and n number of data nodes, what you call. Scroll down, enable component gateway. I can go to configure nodes and you can select whatever type of machines you want in the cluster. So I'm going to use this N1 machine. You get like 4 CPU, 15 GB memory. Okay. And hard disk space, I don't need like 500. I can ask for some 30, right? Then worker node also, I will say 2 worker nodes, just 30 GB hard disk space, say create. See how easy it is. So now Google Cloud is creating this cluster and this is chargeable. Don't try if you're not aware of cloud computing. This is chargeable, highly chargeable. Okay. I think for running this for an hour, they charge $10 or something, even more than that sometimes. So this is highly chargeable, but very easy to demonstrate something like this. So now what Google Cloud is doing, they're creating a cluster for us, right? So you can see the cluster is provisioning, right? And it is happening. Meanwhile, I need to check something. Let's look at Stack Overflow. Okay, anyway, go here. The cluster is running anyway. So we have the cluster running, and why I wanted this cluster is I can just go to the cluster, and in here, um, what I want to show you is, where is the VM instances? Let me connect with the cluster. So how do you launch the Spark shell in the cluster mode? That's basically what I wanted to show you. So in the Intellipaat VM, when I say, okay, start the Spark shell, you're getting something called local mode, right? So here, since we have a cluster, what I can do is I can say Spark shell, then I can say hyphen hyphen help. So if I take help from the Spark shell, you see a lot of interesting things here. For example, the master URL. So the default master is client, meaning by default, Spark Shell is going to start in the client mode. Okay. Sorry, local mode. Sorry. So the default is local mode for master, but you can ask for Mesos as your master, Yarn as your master, Kubernetes as your master, Spark itself as your master. So we will say start the Spark shell and we will say master is Yarn because we have a cluster. What else can you do? Look at this. Driver memory. So how much RAM or the main memory you should give for the driver? So that is the driver memory. And look at this. Executor memory. So how much RAM you can ask for the executor? Then here is the driver cores. The CPU cores you can ask for the driver. And here is executor cores. So let's try to launch Spark Shell like this. I'm going to say Spark Shell, the master is yarn, and I'm going to say number of executors, 5. I need 5 executors. Then I'm going to say executor memory 2 GB. Then I'm going to say executor cores 2 2. Executor cores 2. Then I'm going to say hyphen hyphen conf. Uh, now I need to put this. Spark dynamic. Yeah. Hey, this is enabling. I will try this hyphen hyphen conf I need to give. I think this will work. Let me just check. Give me a minute. Equal to force. I will tell you what I'm doing. So what we are doing here, we are launching a Spark shell, and we are saying that, okay, hey, go to yarn. Okay, just go to yarn and ask for 5 executors, each having 2 GB memory and two CPU cores. So I will tell you what is this dynamic resource allocation, but you can see this started. And now if I go to Spark UI, I will be able to find it. So how do I find this in the Spark UI? I can go to web interfaces. I can go to resource manager, go here. And this is the Spark shell. I open this. I go to this UI. Okay, so you got the Spark UI in the Google Cloud, and here, quite interestingly, expand this event timeline. Can you see there is something called event timeline? And if I expand, it says executor driver added. So this is your driver, which started first. Then you have executor 1, 2, 3, 4, 5. So you can clearly see that we asked for 5 executors and Spark launched it. So first the driver will launch, it will negotiate with Yarn, get 1, 2, 3, 4, 5. So you're getting 5 executors here. You can also go to this executors page here, and it'll show you all the executors. If I scroll down, see, this is my driver. This first thing I'm highlighting is the driver. And below this, you can see 1, 2, 3, 4, 5 executors are there. So these are all my executors launched 1, 2, 3, 4, 5. Okay. So this is something I wanted to show you. Like practically you can see these executors and all, something I just wanted to show you. So you can clearly see here, 1 driver added, then 5 executors. So I will probably delete this cluster because otherwise this is chargeable. So I'm just going to delete this Google Cloud cluster. It's actually chargeable. The Scala programming language. Scala, what is Scala? There is a car by the name Scala, by the way, but I have never heard a Scala as a programming language. What is it? Who created this? When did it come? You know, you tell me Python, you tell me C Sharp or Java. I know this. What is Scala? I never even heard about it, and you are going to talk about it. Well, honestly speaking, Scala is a very popular programming language, but you know it is really popular in the big data landscape. Okay, so if you're even in the traditional world, there are projects which use Scala, but in the big data landscape, Scala is extremely popular. Now, the first question that probably I need to answer is why somebody created a language called Scala? Because there are too many programming languages in the world. Then why did you come up with another programming language. So Scala was created somewhere around, I think, 2004 or 2005, roughly around that. And the real reason for Scala was, I would say, in a way, Java. So if you look at the industry, probably around 2001, 2002, and all, the industry largely had two type of programming languages. Okay, so one type of programming languages were languages like Java. So if you look at Java, Java is in fact one of the most popular programming language, right? Um, and Java is platform independent. Most of you might be aware of that. You can install Java wherever you want, and Java programs are highly optimized. But the problem with Java, now I don't call it as a problem, is that it is very difficult to learn. Now, if you are a newcomer in the programming world and then you try to learn Java, then it's gonna be hard. It's not that easy to learn Java, right? So on the other hand, you had other type of languages, for example, like Python. So the advantage of Python is it is more or less like a scripting language. It's very easy to learn. Anybody can learn practically. So Python code is more or less written like you write English. So the way you can learn Python is very easy. On the other hand, Python lacks some of these optimizations which uh, you know Java provides. So you have like two type of languages. One is probably languages like Java, which have all the benefits of platform independence, optimizations, but they are kind of like a little bit hard to learn. On the other hand, you have languages like Python, which are like super easy to learn. But Python lack a lot of optimizations that languages like Java provides. So Scala came as a language which takes the best of both worlds. So to put it in the technical terms, I would normally say that Scala was the first programming language which supported both object oriented and functional programming styles. So this is the real reason why people started using Scala. So Scala was the first programming language which started supporting something called object-oriented programming and functional programming styles. Now, object-oriented programming is not something new, right? What is object-oriented programming? Languages like Java, C++, they support object-oriented programming, right? In object-oriented programming, we represent classes and objects, or we create classes, and ideally everything should be an object, right? So this is the traditional way of programming, which is known to people, right? There is another way of programming, which is actually called functional programming. Now, I will come to what is this functional programming later. I mean, an explanation and what it is. I will come to that in detail. But functional programming is a way of programming in which you try to minimize the number of lines in your program, right? And you will be using a lot of variety of functions. Like the name suggests, it's called functional programming. So with the use of proper functions, you try to reduce the number of lines of code, and that way of programming is actually called functional programming. There are a lot of more aspects to functional programming apart from this, but in a one liner, if I have to define, I would say functional programming is a way of programming which is fairly easy compared with object-oriented programming. So Scala was the first language which started supporting both styles of programming. And Scala was modeled after Java. So Java was already there, and when Scala was developed, a lot of libraries in Java were reused in Scala. So if you are actually coming from a Java background, you will find a lot of similarities in Scala. However, Scala is a language which is comparatively easy to learn and easy to work with. Now, when it comes to the performance benefits of Scala, right? So first thing we need to understand is that it supports something called object-oriented and functional programming styles, which means if you are an object-oriented person, you are familiar with classes, objects, and inheritance, and all these concepts, you can definitely use Scala, no problem. You can also use it for your functional programming kind of projects. Now, the second interesting point is when you write a Scala program, okay, and then you compile it, the compiled program can be executed on top of something called JVM or Java Virtual Machine. So you remember, if you're writing a Java program, what happens? Any Java program you write, you compile the Java program, it will create something called a jar file. And the Java program requires something called JVM. Scala programs also run exactly on the same JVM. So what is this JVM or Java Virtual Machine? JVM is a platform where your programs can run. The beauty of this is JVMs can be installed on almost any kind of hardware software combination. So the real reason Java programs are platform independent is because you are able to run them on top of JVMs. So on the same line, Scala is also platform independent. So wherever you are able to run a Java program, you can run a Scala program as well. Because as long as you have a JVM, you will be able to run a Scala program. Also, the JVMs provides extraordinary performance tuning. So when it comes to the performance benefits of Scala, it is actually contributed by the JVMs. The real reason why Java programs are so optimized is because they run on top of this JVMs. So Scala programs also can benefit from the JVM architecture. So when you write a Scala program and compile it, you can basically execute it on top of a JVM. So that advantage is also there. So Scala programs, they can be written in object-oriented and functional. Scala programs usually are easy to write. Scala programs can be platform independent. You can run them on top of Windows or Linux or any platform you want because they support JVMs as the platform. Scala programs are also performance oriented because the JVMs allow you to do performance optimizations, right? And usually when you want to work with a language, any language, Scala as an example, the best way to start working with the language is that you start, doing some hands-on with the language, right? So what I'm going to do is Intellipaat has a virtual machine, right? So you will be able to install Scala on the Intellipaat VM. Now I know that some of you might have already installed Scala. In that case, it is fine. In case if you have not installed the Scala, don't worry, I will help you to install. So we will be primarily using this Intellipaat VM as our platform. So what I have done, I have already installed Scala on the Intellipaat VM. So I'm just going to connect with the Intellipaat VM. Okay, so I just logged on here, and you will be able to install Scala if you run a couple of commands. I will share that with you. Once you have installed a Scala, the beauty of Scala is Scala provides an interactive shell. So if you're coming from the Java background, normally what happens, if you want to write a Java program, you always use an IDE, right? Something like Eclipse. Eclipse is an IDE for Java. Now, Scala also supports IDEs, but
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD. B. Data frame. C. Data set. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Scala supports this interactive shell. So I can just type Scala in the command prompt, and what will happen?
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
You will be getting something called the Scala shell. Now, don't worry, I have a small error. Don't worry about it. But as you can see, I have just launched the Scala interactive shell. So the easiest way to get started with Scala is using the Scala interactive shell. You can just type Scala in the command prompt and it is going to start it. I will also show you the IDE for Scala. Don't worry, we will discuss about that. But we will first start with the interactive shell. Okay, so when I start the Scala shell, I want to show you something interesting. What is interesting, right? So I'm going to type something. I'm just going to type 2. So all I did is I typed the number 2 and hit enter. And what you see here is Scala says, hey, you know what? 2 is an integer. This is very interesting. This means Scala can automatically figure out the data types, right? So I never told Scala that 2 is an integer, but what happened? Scala came back to me and said that, okay, did you just type 2? Okay, so 2 is an integer. And this will work for anything. If I type, let's say, oops, sorry. If I type something like 10.3, Scala will tell me that this is a double. If I type something like A, just in single quotes, Scala will tell me it is a char data type. If I type something like Raghu, Scala will tell me that it is a string. So one of the features of Scala is what we call dynamic type inference. So this feature is actually called what? Dynamic type inference. So we are talking about dynamic type inference. What is this? Dynamic type inference means Scala is able to dynamically guess the data type. So anything that you type or feed to Scala, it is able to figure out the data type. Now you may be wondering what is this RES0, RES1, RES2, and RES3. These are system generated variables. See, normally you will say something like A equal to 2, right? So normally when you declare a number like 2, you will assign that to a variable. Now I'm not assigning to any variable, I'm just typing 2. So Scala will create a variable called res0. It's actually called result 0, right? And assign this 2 to me. Don't worry, in the real world, we will not be what? declaring variables like this. We will be doing proper variable declaration, and I will show you how that works. I just wanted to show you that Scala can automatically guess the data type. Also, using the Scala shell, you can do basic mathematical operations and all. For example, I can just say 100 plus 2, and Scala will do the math and tell me that it is 102 and the data type is integer. So the Scala shell is very interactive. You will be able to perform a lot of operations here. And the point that I wanted to clarify here was that Scala has this dynamic type inference. Now, this is very similar to the language called Python. If you are a Python developer, right, then Python also has the same dynamic type inference. So when you go to Python, you just declare a variable and Python will also detect the data type. But there is a difference here in Scala, and I will come to that in a moment. Okay. Now, the next thing that we need to understand is about variables in Scala. So there are two types of variables in Scala. So normally in a programming language, we typically say there is only one type of a variable. But when it comes to Scala, there are two types of variables. One is what we call immutable variable, and this is represented as a VAL. Second is called mutable variable, and this guy is represented as a VAR. And this might be something which is a little bit confusing initially, but I'm quite sure all of you will really get along very well. Um, Only in Scala I have seen this. Now, I may be wrong, my experience also matters, but I have never seen this in other programming languages because in every other language, when you want to declare a variable, you just say a equal to 100. So when you want to declare a variable, you will say something like a equal to 100. But in case of Scala, you need to say this a is a val a. It can be a val a equal to 100, or it can be a var a equal to 100. You can never say just a equal to 100. The a has to be either a val, a val, or a var. What is this val and var? So if you go back to the Scala REPL, we can try to see that. So I can try to declare a variable. I'm going to say val a equal to Intellipaat, let's say. So now this is how you define a variable in the proper way. Uh, I just said, okay, val a equal to Intellipaat, right? So as you can see, Scala is able to tell you that a is a string value. So there is dynamic type inference. Fine, no problem. And the value of a is actually Intellipaat. Now, whenever you declare something as a val or a val, it's immutable. Immutable means something which you cannot change. Meaning, if I try to do this now, if I try to say A equal to, let's say, spark or anything, what will you see? You will see error reassignment to val. So once you declare something as a val, it cannot be modified. Val is immutable, and there are certain situations where you will use them. Maybe when we start discussing Spark, I will come to more details about this. So usually people have a belief that programming means when you have variables and you should be able to modify them. And naturally people will be having this question, hey, what is the use if I declare something then I'm never able to modify. So there are some special use cases, especially in the big data world. When we start discussing about Spark, maybe I will come to that. But as of now, just be aware that when you say val, it is immutable. On the other hand, I can say var b equal to Hadoop, and then I can say b equal to MapReduce. So as you can see, when I declare something as a var or a var, right, I am able to modify that. So var is what we call mutable. So if you're coming from the Java background, these are very similar to Java final variables and non-final variables. Or you can consider them like constants, for example. So whenever you have a val attached, they are more or less like a constant. Whenever you have a var attached, that means you will be able to modify them. However, most people understand this. This is a concept that most of the people get it, because you just need to remember which is mutable, which is immutable. That's all you need to remember. However, there is a catch here, and I think you have to be very careful. What is the catch? The val is fine, because once you declare something as a val, you can forget about it because you are not going to change it. When it comes to var, the var, I just told you that you can modify, but it comes with terms and conditions. What do you mean by terms and conditions? See, I just said B is Hadoop. Fine. But if I try to do something like this, I will get an error. Why am I getting an error? You just told us that you can modify B. Yeah, I told you. However, there is a catch. What is the original data type of B? It is string, right? So this basically means you will be able to modify the value of B, but it has to be a string. So I was trying to assign an integer. Then what happened? I got a type mismatch error. It did not work, right? So this is what we call static typing. So this technical term for this behavior is called static typing. And sometimes people will say Scala is a statically typed language. What do you mean by that? This means once you declare a variable and assign a type, it remains the same throughout the scope. So when I declared B initially, B became a string. This means you can modify the value of B, but it has to be another string. Okay, so that is what you call static typing or statically typed programming languages. Great. So what did we learn about variables? We learned that whenever you declare a variable, there is this feature called dynamic type inference, where Scala will guess the data type. We also saw that there are two type of variables in Scala. There is like immutable and then mutable variable. And there is one more thing that probably I tell the audience, which is I can definitely declare a variable like this. So I can definitely declare a variable saying val z equal to 100, and it works. And Scala is also able to tell me that the data type is integer. But what I have seen in the production is that when you declare a variable, you don't want to, how do I say this? You don't want Scala to guess the data type. See, if you're so sure about the data type, then why do you want somebody to guess it? So a better way of writing the same code will be, you can say val z, it is integer, equal to 100. So you will be able to mention the data type rather than Scala guessing the same. It is your choice. Okay. If you just say z is 100, Scala is definitely going to guess it. I know that. And it is going to be correct. But a better practice will be like this. Now, why this is a better practice? Two reasons. One reason you are sure, right? You don't want the language to guess. If you know that z is an integer, you declare z as an integer. One reason. Second reason, if you already give the data type, then the compile time can be less. Because sometimes what happens, Scala has to take a lot of time. This might be microseconds, but still it matters to figure out the data type, right? So if you're so sure about the data type, then why you want somebody to guess it, right? So you will see sometimes when you look at Scala programs, people will hard code the data type. And I think that is something which you can justify. Even I do that sometimes. Okay. Sometimes during the classes is that, hey, you just told that you will be teaching us Scala for 2 classes. Why 2 classes? Can't you teach like 5 classes of Scala? Right. So that we become like experts in Scala. Honestly speaking, I don't want you to become an expert in Scala. Now, a trainer should not say this, but I really don't want you to become an expert in Scala. And this is a statement which is very dangerous. There are many reasons for that. First of all, when it comes to Spark, right? See, why are we learning Scala? We are learning Scala so that we can work with Spark, right? In Spark, when you go, you will see that the majority of programming can be done using SQL. Right. So SQL is primarily what we use in Spark. We also use Scala, but in the latest versions of Spark and all, predominantly it is SQL, not Scala. That does not mean you should not learn Scala. If you learn the basics, you are going to be just fine. The second reason is when you start working in the industry, like I said, maybe you're working in a company, they may be using Java for Spark. They may be using Python. They may be using R. So the language might change over the period of time. Right. So the programming language, especially in the big data world, usually what people do, they just get a basic idea, right? And then whenever there is a necessity, you can learn if you want, right? And that is exactly the reason we spend probably only 2 days on Scala, and then we go to Spark. And when we actually start Spark programming, you will understand why I told all about this. Okay, great. One of the other reason you are learning Scala is the source code of Spark is written in Scala. The Spark framework, one of the most used big data framework in the world, itself is written in Scala. So it probably justifies somebody learning Scala and programming in Scala because Spark itself is written in that. If you go to Hadoop, right, you have this map reduce, right? And when people learn map reduce, they learn map reduce using Java. Maybe some of you have gone through map reduce classes. And have you ever wondered why you are learning map reduce using Java? One of the reason is because Hadoop itself is written in Java. So it makes sense to actually program in Java because it is more native, right? So probably this is also a similar reason. Spark itself is written in Scala. So accordingly, Scala is a very popular language among the Spark developer community. Okay, we will probably talk about it later. I will just talk about one more concept and then I will get back to your questions. I know that there are a lot of questions. There is one more interesting thing in Scala, which is what we call a block expression. And this is something I might have to show you. So in Scala, you will be able to type something like this. So I can say add equal to, let's say var a equal to 10, var b equal to 20. Then I can say a minus b, Oops, I think that might be an error. A plus B. Yeah, definitely it's an error. I'm sorry. I have to rewrite it. There is no other way. A add equal to, I'm sorry, where A equal to 10, where B equal to 20, A minus B, let's say A plus B. Yeah. So what is this? This is what you call a block expression in Scala. And I think this is something which is very common in almost every programming language. Like maybe you are uh, talking about Java, right? Uh, or even C, right? You see this flower brackets, right? This is called a code block or a block expression, right? In Scala, when you write a block expression, you can say I'm writing it line by line. One thing that you notice here is that there are no semicolons at the end of the statements. So in most of the other languages, when you write something like this, you keep a semicolon at the end of this statement. In Scala, semicolons are optional. You don't have to use them, right? The second thing that I want you to understand is when you write a code block like this, the last expression is always evaluated and assigned to the variable. So now the last expression is a plus b, so that is 30. So that value 30 is being assigned to this variable called add. So I just want you to be aware of this. Okay, so you will find it in many places in Scala that people write a code block like this, and they will be assigning that to an entire variable. So this variable will be taking the value of this last expression that you have inside the code block. So here the last expression is a plus b. So even though it will evaluate a minus b, it is not going to assign that to anywhere. So the last expression here is a plus b, and that is what is going to be assigned to this variable called add. So you can have an entire code block, and then the value of that code block can be assigned to a variable. So this is actually what we call a block expression. This is called a block expression. And with that, we will probably come to one thing. I just wanted to discuss one more concept, okay? And probably I will, maybe I will ask you to guess the output. I'm going to write something, and what I will do. So Scala supports something called a paste mode. There is something called a paste mode. So if I want to write like 3 lines of code in one shot, I can go for a paste mode, right? So what you can do is you can just type colon paste. So when you type colon and then paste, you can see that you will get a message entering paste mode. And what I'm going to do now is I'm going to type 3 lines of code, and I want you to guess the output, just to be familiar. So what I'm going to do, I'm going to say val x equal to, I will say, I want to print a line, foo, then 10. Then I will say, I want to print bar. Then I will say print x. So this is the 3 lines of code that I have written. Can you tell me if I run all these 3 lines, what is going to be the output? Now, this is a block expression, okay? And these are print line statements, which basically print line by line. 3 lines of code, right? So how do you execute these 3 lines of code, right? You can see here, it says Control D to finish. So when you are in the paste mode, if you press Control D, it will execute all three lines. That's how you get the output. Okay, so I will try to do a Control D. This is the output. Foo bar 10 is the output. So I think some of you like Anuradha, then Leta, they got the correct answer. It's fine. Some of you may not have got it. Now, if you're wondering how did you get this output, first thing, this is a block expression. So value of x is going to be what? 10. Value of x is going to be 10. Okay. And since there is an explicit print statement, it will print. So the rule is whether it is a block expression or not, when you have an explicit print statement, it's going to print. So first line is going to be foo because there is a print of foo. Second line is going to be bar because the print of bar. Third, you are saying print x. Okay, value of x will be what? The last part of the block expression, that is 10. So when you say print x, you're going to get 10. So the output is going to be foo bar and then 10. Okay, now this is not what I want to do. I was showing this as an example. This is not what I really want to do. I want to show you something else. So I'm going to rewrite this program in a slightly different way. Okay, so I'm again going to say paste. And instead of typing X, I'm going to say lazy val X equal to, I'm going to say print line foo. So same code I'm going to write, almost same you can say. Yeah. So if you compare this code, what I wrote just now, with the previous code, there is only one difference. The difference is previously I had this X, right? I had this X. Now I just have this lazy val X, right? I have something called lazy val X. Yeah, so if you look at here, the only difference here is between these two lines of code. Here I was declaring the variable x and it was just an x. Here it is a lazy x. So this is what you call lazy evaluation. If I run the code, you will see that the output is different because previously you were getting foo bar 10. This was my first code. Now you are getting bar foo 10. So what happened here? So Scala supports something called lazy evaluation, and that is what I just showed you. You can declare any variable as lazy. So in this particular example, I just added the lazy keyword before the variable x, which means the initialization of this variable will be deferred. What is the word I'm using? Deferred. So this variable initialization will be delayed or deferred, I can say. So when you say lazy x, you're basically telling Scala that, hey, Scala, this variable is lazy. Please don't run this line. It is as good as you're not running this line. So when you do something like this, Scala understands that, okay, X is lazy. I'm not going to run this line. So the first line it is going to execute is this print line bar. And that's what you get here. You get a bar. Then the moment you call this variable in the program, it will initialize it. So then you're calling print X.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and data frame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
Now Scala will initialize this line. You will get a foo and then 10. So whenever you uh, declare a variable as a lazy, the initialization of that variable can be deferred. Now, where will you use this? This concept is built into Spark RDDs. So when we speak more about Spark RDDs, resilient distributed data sets in Spark, I will come back to this lazy evaluation. As of now, just be aware of what is lazy evaluation. Probably you're thinking, why should I do this? Right? I will tell you why you have to do this, but you can make anything lazy. So here this X is actually lazy, which basically means this line is not getting executed. And then you have the print statement. Then whenever you call this variable in the program, it just gets started. So, I mean, it just gets initialized and then this variable is alive now, right? Okay, so that's what you call lazy evaluation. Now, so far we were working on this Scala ID, interactive shell, right? But in the real world, you don't work with the Scala interactive shell a lot. So if you are a Scala programmer and if you want to write a program, you know the shell doesn't support debugging the program, also correcting the program, giving you suggestions. These are all not there in the Scala shell. So typically, what we do is we go for something called uh, an IDE. Okay, so coming back to using an IDE, right? So like I said, uh, one of the ways in which you can write a Scala program, let's say you are in production, is using the help of something called an IDE or an integrated development environment. Uh, some of you might have heard about Eclipse. If you are a Java programmer, then you might have worked on something called Eclipse. Eclipse is one of the most, how do I say, used IDE, especially probably for Java programs. Now, when it comes to Scala, there are many IDEs. There is an IDE called IntelliJ, which is popular. There is also Eclipse. So let us first try Eclipse. We will also go to IntelliJ later. Now, one thing you need to understand is that if you are going to use something like Eclipse or any IDE, right, my suggestion will be install it on your laptop, not on the VM. See the VM, anybody will do like that, right? So if you are, even if you are working in the production, right, and if you get a chance to install an IDE, the IDE will be installed in your developer machine, not on a VM. And in production, you don't have a VM also, right? So what I'm going to do, I will show you how to install this Eclipse IDE for Scala on your laptop. So this can be installed if you have a Windows or a MacBook or anything. All you need to do is just go to Google and search for Scala IDE. So just go to Google and search for Scala IDE, and the first link that comes up is Scala IDE for Eclipse. So you click on the link and directly you can see an option called download the IDE. Now the beauty of this Eclipse IDE for Scala is that once you download this IDE, you don't have to install it. It will come in a zip file. All you need to do is extract the zip file and it will work. So there is no need to install it. I think that's great. At least on Windows, there is no need. I think in MacBook also it is same. You're basically getting a zip file. So I'm using a slightly older version. Like you can see the current version is 4.7.0. I may be using a slightly older version. That's okay. So I have already downloaded this thing. And to see this, I need to check where I have downloaded it. Yeah. So I just extracted the contents to a folder called Eclipse. So here you can see there is an Eclipse folder and there is a file. So once you extract this uh, .ex, I mean zip file, you will be extracting the contents to a folder, right? And then you can just double click and it will start. Now, if you already have Eclipse installed for Java, you can go to this marketplace, search for Scala, install it as a plugin. That is also going to work. I mean, for uh, freshers who are not using Eclipse at all, this is what I recommend, right? Uh, but let us assume you're already using Eclipse and maybe you are using Java. What you can do is just go to the marketplace. There will be a Scala plugin, and you can just add that Scala plugin. It should work, right? So I'm just starting my Eclipse. This is like Eclipse Neon. I think it is slightly older, but it will do the job. See, normally when you write any program, the program is going to have two components. There is something called a driver, and there is something called business logic. I'm talking about a normal program. We are not talking about big data or anything. I mean, any program you write, typically we say that there is something called driver and business logic. Business logic will be the actual business logic you are writing. Maybe you want to find out the top 10 profitable products sold by your company. So you may be writing some program. So this is your actual program, the program that you're writing to find out whatever you want, right? However, in order to run this program, there is a component needed called driver. The driver is responsible for getting resources to run the program, initializing the objects, right? And all this. And typically within the driver, we declare something called a static class. Right. If you again are taking the example of Java and all, when you start writing a Java program, we will say public static void main, then arguments. What is that? So you're declaring a static class in Java, which means that is the after that you have the main method, that's the entry point, right? So a static class is needed. There can be only one instance of it. It's immutable, like most of you said, right? A static class is needed so that you instantiate the driver part of the program, which in turn will get resources called the JVM and then make your code work. And typically in any program, you start by declaring a static class. After that, you will also have something called your main method. When it comes to Scala, Scala doesn't have something called a static class. Instead of a static class, Scala uses something called singleton object. So a singleton object is nothing but a static class. It is probably just another name, but when you start writing your code in Scala, you will never find something called static class. You will find something called singleton object, whatever it is, right? Singleton object. So I will show you. So let us try to do one thing. Let's try to create a simple control structure. So when we learn new programming languages, we also talk about control structures like your for loop or if else loop. These are all called control structures. So what I'm going to do, I'm going to go to my Eclipse. So I just started Eclipse. And the first thing you normally do when you start something like Eclipse is that you go to File and you will say New, and then you will say Scala Project. So first thing that you do is you go to File, New, Scala project. Okay, so you select this, you select your Scala project. Okay, and you are supposed to give a name for your project. So I'm just going to call it as I don't know. So first thing that you need to do is you're supposed to create a project within your Eclipse, and within this project you see a source folder. You can definitely have a package and all inside this, but I'm not getting into those details right now. What I'm going to do is I'm going to right click this source thing, and there is an option called new, and I can say here Scala object. So the first thing that I'm going to do is I'm going to create something called a Scala object. What is this Scala object? This is your singleton object or the static class. So I'm going to give a name. Let's call it as if else. Any name will do. I'm just going to call it as if underscore else. So you can see in my code, it is object if underscore else. This is equal to typing static class, whatever class name that you want. Okay. And below this, so once you declare your singleton object, the first thing that you do is you define your main method. So you can say def, you can say main, and the main method can take arguments as an array of string values by default. You can change it. Okay, the default is your program will be able to take arguments as an array of string values. And now you will be able to type your code. So this is like the bare minimum boilerplate code you need to write a Scala program. You need a singleton object, or call it as a static class if you wish. You need a main method, right? Main method will mark the entry of your program execution. These two are actually your driver. These two are actually your driver. They are not part of your business logic, but they are required to run the program. For example, if you want to pass some runtime arguments, you use this argument option, right? Same like that. Now let's try to create a simple if-else loop. I don't know what if-else loop I will create. So let's say there is a variable called fruit and the value is apple. Uh, if I say, I'll say if fruit is apple, println red, else println no color. I don't know what this is, but this is my loop. So probably this is not the best program that somebody can write, but I think you got the idea. Simple control structure or if else loop. So I have a variable called fruit. The value is apple. I'm saying that if the value is apple, just print red. Otherwise, print no color. Okay. And how do you run this? You can save it. Just right click, say run as Scala application, and you get red. No surprises there. You are going to get red. So Scala supports a regular if-else loop. And there is no magic in this. If-else loops are same across almost all the programming languages. You can even go to a else if condition. So this is like you are validating only one condition. I had another example. Let me check. Yeah, this one. So here you can see this program. Yeah. So this is a program to calculate the grade of a student based on the mark. You can see the student has got just 10 marks. So the variable x is the mark. And then you're saying that if the mark is more than 80, then print grade A. Else if the mark is between 65 and 80, grade B, 50 and 65, grade C, 35 and 50, grade D, finally fail. So if you have a series of statements to evaluate, you can use a combination of else if statements, right? And if I try to run this, what will happen?
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
You see the student is failed because he got only 10 marks, right? So all these type of else if conditions are supported in Scala. Yeah, so this is how you write a simple Scala program. Let's try for a while loop. I just wanted to show you a while loop and a for loop before we wind up. So how do you write a while loop? I'm just going to create one more program. So you say new Scala project, call it as my while loop, and I'll copy this main method probably. There is a shortcut I can use, but I like it this way. So you can say var I equal to 10. And how do you write a while loop? You write a while condition. The condition is, let's say I greater than 0. You want to print something. Hello plus I equal to I minus 1. So what is a while loop? It basically checks for a condition and then execute the statement. You can see I have a variable I, the value is 10. And then I say, as I is more than 0, just print hello and the value of I. So this is basically string concatenation. So when you say hello plus I, this is actually a string. It'll add the value of I here. Then in each iteration, you are uh, subtracting 1 from I. So eventually it will reach 0 and the condition will be broken. Simple while loop, right? And if I try to save it and then run it, you can see that I'm getting the hello 1098 up to 1. Uh, so while loops are also very common, and in Scala also there is no speciality the way the while loop execute. Let's try a for loop as well. I will give you more examples, don't worry. If you're thinking, hey, how do I learn a couple of more while loops, I'll give you examples, don't worry. But let me do one for loop as well. I'll copy this. And for the for loop, uh, the syntax is slightly different. See, for loops are normally used to iterate through something and produce the output. So normally in other programming languages, you will say I equal to 0, I plus plus, this kind of a syntax. In Scala, it is very simple. You can say for I in the range of 1 to 10, you can just say print I. So this is how easy it is to write a for loop in Scala. The way I wrote it is, I said for, this is I in the range of 1 to 10. This is like I plus plus, I is iterating from 1 to 10. But you may be wondering, what do you mean by 1 to 10? Are you writing something like in English? 1 to 10 seems to be something different, right? See, 1 to 10 is a scalar collection called range. If I go to the Scala shell, if I just type 1 to 10, it will produce numbers from 1 to 10. It is a scalar collection called range. So you can see range of numbers 1 to 10. You can say one to anything or anything to anything basically. It will generate a numbers like an array, you can say. Range is another collection. You can also say 1 to 50 by 2. It's very interesting to work with Scala. So when you say 1 to 50 by 2, what it means? The numbers are going to be from 1 to 50. The step function is 2. It will start with 1, keep on adding 2, 1, 3, 5, 7, 9, blah, blah, blah. So again, this is again a range. So I'm just iterating through this range and printing the numbers. That's what you're using the for loop. So when you say 1 to 10, I can take values in this range, and you can say print I. And if I try to run this, you can see you're printing numbers 1 to 10, right? So now coming to learning Scala. So I want to share some more information before we wind up. Of course, important information. So first things first, where can you find all the material? Now I'm talking about Spark and Scala in general as a course.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So, see, the idea is very simple. When we broadly discuss big data processing, we usually say there are two kind of processing. One is called a batch processing, right? And then, so I'll probably write it here somewhere. So we have something called batch processing. So in batch processing, what happens is that, you know, you have a data set, you write a piece of code, and it is no longer real time that the processing. That is why it is called a batch processing. A common situation will be that imagine you have an RDBMS system, right? And there is data getting stored in an RDBMS system. And end of the day, I want to find out, let's say, what are the total number of transactions happened, total amount credited, so on and so forth. Imagine you're working for a bank, right? So in the bank, what happens? The transactions happen every day, right? And at the end of the day, you have to close it, right? So you do something called EOD, end of the day processing, right? What are all the, how do I say, transactions which happen during daytime? At the end of the day, you read all of this, you process it, you store it, you will also do some basic analysis if you want, everything. So what is happening is that the data is getting stored over a period of time, and later you are doing the processing. It can be daily, it can be weekly, it can be monthly. So an e-commerce company would like to know, somebody like Amazon, which which type of, let's say, mobile phone was sold the most last quarter. So when they want to look at it, let's say Amazon would like to know which brand of mobile phone was sold the most last quarter. So when Amazon would like to know, all they need to do is look at all the transactions happened in the last 3 months, right? And then write a query. It can be SQL, it can be a program to figure out that. So the interesting point here is you have already collected the data, right? The data is already being collected and the data is already being saved in some place, right? All you need to do is figure out what kind of a program you need to write on the data. And so far, what we were doing is batch processing. So far, if you look at in our course, whether you're talking about RDDs, whether you're talking about Spark SQL, or let it be MapReduce, let it be Apache Hive, all these are classic examples of batch processing. And Hadoop itself is designed as a batch processing system. If you read the original definition of Hadoop, it would say that Hadoop is nothing but a big data batch processing system.
Why? Because on those days, in the earlier days, when you look at big data, it was practically impossible to talk about real-time processing. All that we were able to do was batch processing. And this is not a new idea. If you look at mainframe computers, they do batch processing, and batch jobs are very common, right? But what we are really going to discuss is the other section called real-time processing, right? Or it is also called streaming. There are many names for this. It's called streaming, it's called real-time processing. So, hey, what is the difference, first of all, when you say real-time processing? The classic difference is that you process the data as soon as the data arrives. You are not going to store it. That is the classic difference between batch processing and real-time processing. I'm getting the data, and as soon as the data comes into my system, I'm going to process it. And I want to make some sort of a business decision based on real time data, right? So you may probably wonder that, okay, so are you saying that the RDBMS systems or NoSQL databases, they do real time processing? Not really. That is not what we call as real time processing. Well, they work in real time. We know that. So if you look at an RDBMS system, it is completely transactional. It follows ACID properties, and it works 100% in real time. But all the RDBMS system does is store the data or insert, update, delete, or whatever you are doing, right? You are not really analyzing the data. You're just making sure that the RDBMS is efficiently storing your data. On the other hand, my requirement is given data in real time, I don't want to store it anywhere. Okay. I want to process it as soon as when it arrives. Now, this may seem very simple, but it is not. Look at the challenges. First of all, you are not sure how much data is going to come in. That's one problem that we have. Second, you need to process, and the processing has to catch up. For example, if you're getting really good amount of data in real time, if your processing becomes really slow, then it is no longer real time processing, right? So your system should be capable of processing this really fast, and you cannot have any kind of failures. Failures are not at all accepted, because if you fail, if your system fail, you are missing real-time data. Well, you're saying theory, theory, theory. Can you give me some practical example of what we're talking about? Some business use case of what we are talking about? Yes, I can give you 3 examples where I have worked myself, which will give you an idea about what we are talking about, right? So there are 3 use cases which I personally would like to talk about. One is from the e-commerce industry, e-commerce. Second is this banking. Third is advertisement. Well, there are plenty of examples. These are my experience. So in the e-commerce industry, what we do, I was working with Flipkart, not now, like in 2015 and all, as a consultant. So I was looking at, I was observing what they were doing, and in e-commerce industry, there is a real interesting thing that happens. For example, I think the sale is on now in Flipkart. Flipkart runs a sale, and I think they have a sale now. Let me just check. Yeah, so there was a sale on Flipkart which ended yesterday. So how do these sale things works, right? So if Flipkart announces that there is going to be a sale today, right? What they do, in fact, is that they will expect some traffic, people to come in and try to buy stuff, because they have announced the sale and a lot of marketing has done, and people are definitely going to come. So that's not their problem. Their problem is they may not know what they will buy. Well, you can predict for sure. So deep learning, machine learning, everything we use, but you can predict up to certain extent, but you're not really sure what people are going to buy on the website. So what they do, one thing that they does, apart from all these things, is that they are going to look at, how do I say, the data in real time. For example, Flipkart will announce that there is going to be 40% sale on mobile phones. They will not say which mobile phone. Sometimes they say, but in most of the cases, they will say, okay, we're going to give you 40% sale offer on mobiles. Now, what happens? People rush to the website, and what they do is that they collect the data in real time. The kind of data we call it as clickstream data. For example, where are you clicking? What are you searching in the website? So, if I can figure out that in the last 20 minutes, most of the people are searching for Apple iPhone. As an example, I'm saying Apple iPhone 8 or something like that. I can put up offers and ads specifically on iPhone so that people will buy it more. I will know this only when I look at real-time data. So one thing that they do is this dynamic pricing and offers. So they do something called dynamic pricing and offers. Based on the user activity in the website, they have to adjust the offers, the pricing, the discount, everything. So the site is dynamically getting adjusted based on your user traffic. The second thing, there is a dynamic inventory management. For example, if lot and lot of people are ordering a particular item, you will run out of stock. So you need to manage your inventory. This has to happen in real time, right? So also their entire product inventory has to be managed in real time, because end of the day, you need to sell everything, right? So depending on what users are searching for, what is their interest, you have to give them offers and make them buy. So that is an example of real-time analytics, because even though you understand the users, what they might buy, might not buy, not everything can be 100% predicted.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD. B. Data frame. C. Data set. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So using Spark as an example, what they did is that they built this real-time pipeline where they monitor user activity and try to figure out the best offers for each user. So that's one thing that we do in the e-commerce industry. The second example comes from banking. In banking, what happens is that this is very common, but there is something called credit card fraud detection. So, see, during festival seasons and all, people use their credit cards like crazy, right? Because you don't want to pay money, you may not have money, right? So you use your credit cards like anything, crazy, right? Now, how do you know whether a credit card swipe is a fraud or not? You don't know, right? Also, they want to segment the transactions, credit card fraud and segmentation. So what happens? You could have experienced this. If I swipe my credit card, let's say my limit is 1 lakh rupees, and if I swipe my credit card for like 70,000 rupees, I will get a call from customer care. They will ask like, did you really swipe your card, right? Because they suspect that it is a fraud transaction. Or if you say that yes, I did, then they will ask, do you want to convert it into EMIs, right? So how does this system work? So again, the requirement here is that I have to collect millions of transactions, say per minute, right? And I have to feed them into a machine learning algorithm. So multiple things we do. First, we do a basic level of check. For example, the location check. Say if you're swiping your card, the bank can understand the location. So we do a location mapping, basic location mapping, and then we do a limit check and so many other things. And then we feed this data to a machine learning algorithm, which will predict whether it is a fraud or not. And then the actual call will go to the customer. So the challenge here is I'm looking at millions of transactions every minute. And for each one of them, I need to make a decision real time. How do I do it? Right? So that's a very common use case. Third is advertisements. So this is your real time ads. So you go to these websites and you see these ads. The ads are based on your cookies, right? The ads are based on your cookies, that the information they save, but there is a requirement for customization of ads as well. For example, if you're looking at a red bus, right? So you're trying to, or let's say you're looking at Make My Trip, flight booking, flights. So if I look at Make My Trip flight bookings, right, the problem for the Make My Trip is that I might be searching a flight from Delhi to Mumbai. So when the ad has to be shown, it should have Delhi to Mumbai. They cannot show a generic ad, right? So this data has to be captured in real time, first of all. And then they need to make a decision whether the ad need to be shown or not. If yes, the ad has to be shown with this particular data. So if I'm searching from Delhi to Mumbai, I should see an ad of Delhi to Mumbai only. Then only I'll book my flight, right? If I see a very general ad of Make My Trip, probably I'm not interested, right? And also these customized ads that you see on many websites. So all of this has to do with real-time data analytics, right? So if you ask me, this itself is a huge field actually. Real-time data analytics itself is kind of like a very, very big area, right? And to look at a bit of history, initially we had somebody called Apache Storm. Apache Storm is probably one of the earliest, how do I say, earliest use cases for real-time data processing. And in my opinion, Storm is probably the most popular one as well. Not now, but at one point in time. Storm came long back actually. Okay, I think somewhere 2012 or 13. So in those days, there was absolutely no way to do real-time processing on big data, right? So Storm is an independent project. The problem with Storm is that you have to learn it, you have to install it and manage it separately. Storm has nothing to do with Hadoop or any of these things. So everything has to be. So if I have to implement real-time processing, I need to sit and learn Storm and then understand what it is, install it, integrate with Hadoop, and so on and so forth. Unfortunately, I have not worked on Storm. Okay, I know people who work, but Storm is a great, what you say, real-time processing engine, in my opinion. So Storm was one of the early real-time processing platforms we had, right? But the real deal here, what we are really talking about is this guy called Spark Streaming. So Spark has a module called Spark Streaming, right? And Spark Streaming is the module in Spark which can do real-time processing, right? And this is like crazy. Why this is crazy? Because if you look at the industry, there is also somebody called Apache Flink. There is somebody called Apache Flink. There is also somebody called Kafka Streams, which is getting a lot of traction these days. Kafka Streams, etc. So these are all different products which can do real-time processing, or probably I can say competition to Spark Streaming. Now, there is a difference between collecting the data in real time and processing the data in real time. So if you look at Kafka, the original Kafka is a data collection mechanism, or I can say a message queue. So what is Kafka? Kafka is a platform where you can collect the data in real time originally. But what they did, I think for the last 2 years, they developed something called Kafka Streams. Kafka Streams is basically analyzing the real-time data. So everybody is into an analysis. Even if you go to Amazon, AWS, the cloud, Amazon has something called a kinesis or kinesis, whatever you call kinesis. So real-time analytics is a very hot thing in the industry now, and lot of companies are investing their money. I know only this. There can be plenty of other products in the real-time analysis market, right? But these itself are like competing for the number one position. But among all of this, Spark Streaming seems to have an edge, right? Why? So see, there are a couple of things which are really interesting about Spark Streaming. So I'll probably take Spark Streaming because that is our topic. Well, some of the other products can also do it, but what is so special about Spark Streaming, right? When you talk about them, the first advantage is that, for example, it is completely fault tolerant. When I say fault tolerant, in most, how does it work? It works basically on the idea of, how do I say, sparks fault tolerance only, right? But in most of the cases, it is highly scalable and fault tolerant, Spark streaming, right? But the real deal here is the integration with other libraries. Look at Storm, for example. So if you're working on Storm, I think now they support it, I'm not sure. But in the earlier days, what used to happen is that, okay, I built a real-time pipeline. No problem. I'm getting data in real time. I'm processing data in real time. Everything is working happy with Storm. So Storm's job is analyze the data in real time. For example, you are getting credit card data, credit card swipes you are getting, and Storm is processing this data. However, if I want to apply, let's say, a machine learning algorithm, if I want to develop and apply a machine learning algorithm, that is not directly possible with Storm. Storm is not designed to work on machine learning, at least the original Storm. So the problem for you is I have to write my machine learning algorithm separately, say using Python or something. Then I have to deploy it. Then I have to integrate that with Storm. So Storm naturally doesn't understand machine learning or doesn't work with machine learning. And if my algorithm changes or if I have to modify any of this whole integration process has to happen again. The advantage with Spark streaming is that since everything is under a single umbrella, RDDs, Spark SQL, Spark streaming, machine learning, it can seamlessly work. So if I want to write a machine learning algorithm, I can use Spark. Spark has a library called MLlib for machine learning. In fact, Spark is the #1 product when it comes to distributed machine learning. As of now, when you look at the number of people who are using machine learning on big data, Spark is the #1 product, right? So I write my machine learning using Spark. I do real-time processing using Spark. Everything is inside the same thing. So there is no hassle of, and the data also can be interchanged. So I don't have to depend on a separate framework for machine learning, separate framework for streaming, etc. Everything works seamlessly, right? So I can even write SQL queries if I want, because Spark SQL also works very well. So the integration is the really upside of what you say Spark streaming, right? Which was not possible with Storm. I think now they do it. There is a product called Flink. Flink also does almost what Spark does, but it is not very popular in the market. Kafka streams, in my opinion, they do not support machine learning right now. Amazon Kinesis does not support directly. You have to do it separately. But Spark is probably the first framework which started supporting this. And the third advantage is you don't have to learn anything new. What do you mean by this? So if I'm using Apache Storm or Apache Flink, I have to learn their language, their API, how they work, how to write a program. When I'm using, Spark streaming is what, end of the day, it is nothing but a continuous flow of RDDs. So any program that I write in Spark streaming is nothing but transformations and actions. So you don't have to learn anything to write a Spark streaming program, honestly, right? So right away, a developer can start writing streaming applications. That is wonderful, because otherwise, if you look at other projects, the hard part is learning how this works, right? So here, if you look at Spark streaming documentation, I will show you. It will have all the regular transformations and actions that you are familiar with in Spark. Now, I must also tell you a couple of things since we are in a training, right? Um, Probably I can go to the documentations to talk about it. If I go to spark.apache.org, let's say we pick 231, sorry, 231. If you give me a moment, let me just look at SQL one thing, okay? Yeah, so if I go back and look at, let's say, streaming documentation, here it says there are two things when it comes to Spark streaming. There is something called structured streaming, and there is something called Spark streaming. I should tell you about this because otherwise you will go and ask, hey, why didn't you talk about it? See, Spark streaming is the original API. It's called old API because it is the original API. So what we are going to discuss is Spark streaming, and this is the original API. And here what happens, what you do is that you create a stream of data, a real-time data, and under the hood, everything is RDD. So if I want to do analysis in real time, I need to write transformations and actions in Spark streaming. Structured streaming, what happens? Again, the same idea. You create a streaming program and data comes in real time, right? But under the hood, the data is treated as a data frame. So basically, you can write SQL on top of real-time data. That is called structured streaming. That is rather a new idea. So to be really honest with you, I have not worked on structured streaming a lot because structured streaming came almost a year or two back, right? There are people who are working on structured streaming, but I don't have much experience on working on structured streaming. So we have Spark streaming. The difference is that here I use RDD, here I use Spark SQL. And obviously, going forward, I think people might switch to structured streaming, right? Because data frames and SQL are the norm these days, right? So there are two ways to look at this. We are going to look at the Spark Streaming API, the original Spark Streaming API, right? And if you look at here, so there is a documentation for this, but if you look at somewhere, it will be written, yeah. If you look at transformations on D streams, see map, flat map, filter, repartition, union, count, reduce by key. So these are all the things which you already know from the RDD class. So there is nothing new on when it comes to transformations on Spark streaming, right? And D stream is nothing but the API that we use. What is D stream? D stream is nothing but a continuous flow of RDDs. So your primary requirement in Spark SQL was to create something called a data frame. If you remember Spark SQL classes, what we were doing, the first step that we did is that we learned how to create a data frame from an RDD, from a Scala collection, etc. In Spark streaming, you have to create something called D stream. D stream represents a continuous flow of data, right? It represents a continuous flow of data from any source, real-time source, right? And then you write your programs on D stream, your transformations on D stream. So you need to create a D stream. Once you have the D stream, it starts working, and then you write your code on top of the real-time data. And all of this is by default in memory. So this happens in memory, in the sense the data will flow in real time to the cluster. Your Spark cluster will keep the data in memory and do the analysis on the data in memory. And the output, you can decide what to do with the output. You can store it, or you can display on the screen, or anything like that. So the important point here is that we are not interested in the original data. For example, there are many use cases where you do real-time analysis on social media data. And I will show you an example, right? So what we will do, we will connect with Twitter and stream all the public tweets live. And then we will do some very basic analysis on these tweets, right? So what this means is that, let's say you are analyzing Twitter data. So I want to know which football player is trending. So this Lionel Messi, or I don't know, Cristiano Ronaldo. So based on the number of tweets and people talking about the football player, I want to know which football player is trending in Twitter. So what I did, imagine you started collecting all the tweets related to football. The point I'm trying to tell you is that you are not really interested in storing the tweet, right? In fact, the tweet is not really important at all. You are interested only in the output. So if I'm getting 1 million tweets about Messi, I get the output saying that Messi equal to 1 million and Messi is the number one trending player. That is what I want to store. I don't want to store 1 million tweets. It's useless. There is no use for storing 1 million tweets because this real-time data is useful only at the time of its generation, right? Yesterday's tweet is no longer relevant today unless you want to do some really hardcore batch processing on that data. But usually that is not relevant. Yeah, sometimes we do it. Sometimes what we do is that we get this data, we store it as well so that we can analyze it in future. But when it comes to real-time analytics, more or less we depend on the output, right? Yeah, so you just want to see the stats and you want to just store it, and that's what we do. Now, there are some slides. Basically, what I explained is this slide so far. So I'm gonna go to the important part in the slide. So Spark streaming is used for processing real-time streaming of data. It is a useful addition to the core Spark API. Spark streaming enables high throughput and fault tolerant stream processing. We have seen that. Yeah, so this is probably something that you can relate to. This is how a typical stream processing workflow will look like. So what you see here is that you will have sources. The source of data can be, I don't know, if you're collecting chat messages in real time, it can be a chat server, it can be social media, it can be credit card swipes, it can be data coming from your mobile phones, it can be data coming from sensors, it can be anything. Any system which generates data in real time can be a source. Now there is a intermediate part called data ingestion. So data ingest, the second part. See what happens, you might need an efficient mechanism to collect the data. That's what I'm saying. So you have two approaches here. One approach is that Spark streaming can directly get the data from the source. That will work if the amount of data that you're getting is limited. For example, imagine you are looking at credit card swipes on a typical, how do I say, non-seasonal day. Let's say you are looking on a Wednesday, right? So maybe you're getting an average of, just an example, okay, 100 swipes in a minute. Imagine you are getting 100 swipes in a minute. So you see, if that is your requirement, all I have is like 100 swipes in a minute, and I want to collect it and analyze it. Probably Spark can directly connect with the system where the swipes are landing and then process it. But if I'm getting like 1 million swipes in a minute, directly collecting this data using Spark may not be a good idea, because end of the day, Spark is not a data ingestion system. So that is where these guys called Kafka, Flume, all can help you. Kafka, Flume are data ingestion, what you say, systems. What they do, they are not same, and also you cannot compare them. So many people do a comparison between Kafka and Flume. In my opinion, you should not really do a comparison between Kafka and Flume because they don't have anything in common unless they collect the data. That's the only point. Kafka is like a distributed message queue. Flume is a point-to-point collection agent. What Flume does, it takes data from one point to another point to point, right? For example, I have a web server which is continuously generating log files. I want to collect it. I can use Flume. One side of Flume will connect with web server. The other side will connect with wherever you want to dump the data. That's it. Point to point data. Kafka, on the other hand, what it does, it first of all, it is like a publish subscribe system. People can send data to Kafka and it will store it. And then anybody who want can subscribe and get the data from Kafka. So Kafka can store terabytes and petabytes of data if you want temporarily. So the idea behind Kafka is that multiple people can send the data and multiple people can receive the data, and all of this can be stored in a distributed cluster. Kafka typically you install in a cluster. Okay, so depending on your use case, you might use Flume or you might use Kafka. depending on what. Kafka is like a publish, subscribe kind of like a platform. But let us assume that you have a data ingestion platform that ingests the data. Then Spark Streaming gets the data from any of these guys. It processes the data in real time, right? And the output can be stored wherever you want. You can store it in Hadoop, you can store it in Cassandra, or anywhere you want. Finally, somebody like Tableau can connect with these systems and visualize the data. So if let's suppose you have Tableau, you have created a Tableau dashboard, it can connect with your Cassandra or Hadoop or anything and visualize the data. That's a typical workflow that I'm talking about, right? Ashwin was saying basically pooling the low data in one place and analyze it. Yeah, yes, correct, right? So here the point is data ingestion is basically why do you want to do data ingestion is to avoid missing data, because Spark Streaming, even though it is 100% fault tolerant, if it crashes for some reason and restart the processing, you may lose some part of the data. If you are using an ingestion tool, something like Kafka, it never fails. So whatever data you're getting in real time will be in Kafka. Even the processing engine loses connectivity, crashes, or anything, it can get it from this part actually. So in Spark Streaming, we create an object called a streaming context. And this is important, right? So whenever you write a Spark Streaming program, Spark Streaming application, you create something called streaming context object. Why do you have to create this object is because this is the object which helps you to set the configuration for streaming. The configuration for streaming may be different than your traditional Spark programs. The most important point in Spark streaming is that people often call it as micro batch architecture. That can be a specialty, that can be a drawback. What do you mean by micro batch architecture? See, what Spark streaming actually does is that when you create a stream, real-time stream, okay, let's suppose you're processing credit card swipes, right? So you have already created a D stream and you're collecting the data. Now you want to process it in real time. When you say, I want to process it in real time, how do you want to process it in real time? Many people think that each transaction will be processed independently. No, that does not work. So ideally, when you say real-time processing, let us say if you are talking about credit card swipes, ideally, real-time processing means even if you are getting 1 million swipes, each swipe has to be processed the moment it is arrived in the system. But in case of Spark streaming, we use a concept called batch interval. We use a technique called batch interval. So basically what you do, you have to set something called batch interval. Batch interval is basically a time. It can be hours, minutes, second, microsecond, anything. So let's suppose the batch interval is 1 second. So what will happen every 1 second, how much data that you have collected, it will process. So in a way, it is batch processing in real time. That is why you call it as micro batch architecture. So if I set my batch interval as 1 second, what is going to happen in Spark streaming is that every 1 second, the last 1 second, how much data it has collected, it will process.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and data frame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
So it may contain 3 credit card swipes or 300 credit card swipes. But it is all time based. It is not transaction based. That is the difference. And the batch interval can be increased or decreased, which is a good thing. For example, if I'm looking at my e-commerce example, right? I want to know how many people are searching for Apple iPhone on Flipkart. I don't want to know this every second. It is useless for me. I want to know this every half an hour. So there my batch interval is half an hour or probably 15 minutes. So I want to adjust my ads based on what people are searching on my website. So I don't want to process each user what he is doing every microsecond. That is useless for me. Basically, I just want to process the user activity every half an hour or every 15 minutes. In that example, batch interval is very much useful because my batch interval can be 15 minutes. So Spark Streaming will wait for 15 minutes. Every 15 minutes, it will apply your analysis for the last 15 minutes data. So batch interval is what we need to use in case of Spark Streaming. That is why it is called micro batch architecture. So if you are looking at real time processing, the batch interval will be very slow, 1 microsecond, etc. But on the other case, again, you want to know which football player is trending on Twitter. I don't want to know this every second, right? I want to know every 10 minutes who is trending or every 1 hour who is trending. So you collect the data for 1 hour, then process it. So it looks like batch processing, but it is not. It's continuously happening. That's what I'm saying. So streaming context, yeah. So these things like setting the batch interval all have to be done by on this object called a streaming context object. So this is what I was talking about. The data stream is divided into batches of X milliseconds. In this example, milliseconds, it can be seconds, it can be minutes or anything. So processing Spark data stream. Imagine your batch interval is 1 second. It will first process data from 0 second to 1 second, then 1 second to 2 second, then 2 second to 3 second. So every 1 second, last 1 second data will be processed. That is how you control this. Okay. No, all streaming tools do not work on a micro batching model. In my opinion, only Spark works like this. If you look at Storm, Storm doesn't work on micro batching. Storm has real-time processing. It is event-based. Each transaction, each event can be processed individually. Is it good? I don't know, honestly. It's not good or bad. That is how they work. Okay, so Storm is more event-driven. Spark is more time-driven. So here time is what we use to chop the data into small parts. Their event is what you use to chop the data, right? So both have a different architecture. Even Flink, I think, is based on kind of like events only, I guess. So this is now this is what you need to understand: streaming source and destinations. Let me see if I have an example of this. Yeah. So when you want to create a real-time streaming program, the first thing that you need to figure out is from where am I getting the data? That is the source. Now, there are multiple types of sources supported. There is something called file-based source, HDFS, network-based source, TCP socket. I will show you an example of these two today, right? Then there are other sources, we call them advanced sources, like Twitter, Kafka, Flume, so on and so forth, Kinesis. So Spark Streaming can process the data, which can be given by Kafka, Flume, Twitter, Kinesis, all these guys, and much more. So if you look at the number of sources, there are many. Right. So they classify that into basic sources and advanced sources. Basic sources are the one I have highlighted now. File-based source HDFS, network-based source TCP socket. They are called basic sources. The remaining ones, Kafka, Flume, they are all called advanced sources. I will demonstrate. And you see in production, what happens is that the data collection will normally be not handled by the developer. It will be handled by the administrator. Because if you're a developer, chances are very low that you will have permissions and authorization to modify stuff and change the data streams and all. So if I'm a developer working on Spark Streaming, I'm probably interested in writing the program. Then I will go to the administrator and say that, okay, this is a Spark Streaming program. It is supposed to get data from Kinesis. So he will figure out how to get the data from Kinesis. What kind of a plugin or connector need to be used for Kinesis and so on and so forth, right? And the major challenge that we have is that once you write a Spark Streaming program and deploy it in production, it runs 24/7, unlike batch processing. Batch processing will stop once you get the output. We have customers who are running Spark Streaming programs for the last 2 years. They have submitted the program in 2017. It is running today without stopping. And that is how the requirement is, because you cannot stop it. It is real time, right? So as long as the data is coming, it has to run. So the challenge here is for resources. And a lot of people ask that question to me. How do you manage resources? Because in batch processing, I can manage resources. In real-time processing, when I look at it, Spark requires this executors and RAM and processor core. What will happen if you start getting data which you cannot handle, right? What will happen if resources are not enough for your processing? So there are many approaches to this. There is one approach where we fix the number of resources and we deal with the input data, amount of input data. We make sure that the input data is within a threshold. It does not cross, right? Because otherwise the processing will become slow and it is no longer called real-time processing. But there is another approach where in Spark, I can do something called dynamic resource allocation. So in Spark, there is a technique called dynamic resource allocation. Dynamic resource allocation. What is this? In dynamic resource allocation, I can submit a program to Spark and tell Spark that, okay, I want to start with 2 executors and I can go up to 100 executors. You adjust accordingly and Spark will do it. So this is quite useful in kind of like streaming applications and all. When it comes to streaming, the data might change, right? So you have to adjust the resources automatically. So I can say probably I want to make use of dynamic resource allocation, and accordingly, Spark will automatically adjust the what you say executors in your cluster. And we do this sometimes. It is good that we have something like this. So you need to set up something called a resource allocation policy and so on and so forth. I can give you something to read about this. Databricks, Spark, Dynamic. So there is a Databricks page. It's a video basically. This is an old video, 2016, but the concept is same. So just go through this if you want to know how dynamic resource allocation is working under the hood, right? There is a video for that, right? Well, it's basically talks about how do you scale your executors, how do you scale up and scale down your executors based on the data that you have, right?
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
What is Spark RDD? So now that we know what the basic features of Apache Spark and what Apache Spark is, we can now move on to the Apache Spark RDD. So RDD stands for Resilient Distributed Datasets. So when we start up Spark, in Spark, basically it is the fundamental building block of Apache Spark framework, the fundamental data structure of the Apache Spark framework. So the RDDs are immutable distributed collection of objects. So they are immutable in nature, and each data set in an RDD is divided into logical partitions. So because we are using this on a distributed file system, the data sets that are present inside an RDD are divided into the logical partitions based on the division that is required on the different nodes of the cluster. And RDDs can contain any type of Python, Java, Scala objects. So basically, RDDs are very easy to integrate with Python, Java, Scala objects, or R for that matter. So those are the benefits and what basically the general idea of a resilient distributed data set is. So now we will move on to the workflow of the RDD. So here we have on the left hand side, as we can see, RDD1 and RDD2. So they are combined, and there is a distributed acyclic graph. So basically we can see that there is a DAG scheduler, which means the combinations are then further combined, and then the combinations are further processed. There is a task set. The task set basically means that there's a cluster manager and there's a task scheduler as well. So the tasks are scheduled, jobs are scheduled in the order of the creation of the jobs, or in the order of basically the resources that are available. So these tasks are scheduled, and then basically when the scheduling reaches the point where the tasks have to be executed, the tasks are executed in the executor where the threads and block manager are present. So the threads basically means the availability of the slots where the tasks would be executed, and the block manager basically means the combination on all of the nodes that are basically present within your cluster where the data blocks are present, and the further combination, the further processing of the data occurs. So now that we know what the RDD workflow is, we will now move on to the type of RDDs that we have. So there are different type of RDDs. As per Spark source code, RDD is an abstract class having few methods. So there are not a lot of methods that are present in the RDD, but there are a lot of transformations that are present in the RDD, which is very important when we are processing big data, because we need to transform data a lot. So let us look at the different types of RDDs. So firstly, we have our parallel collection RDD, where we can see that we've created a value A. This is a Scala shell, by the way. We're using the SC, which is our Spark context variable, dot parallelize. And there are two elements to it. So basically the partitions that are present inside of this value, inside of this RDD that we've created, are two partitions. So when we run a.partitions.size, we basically get 2. So that is essentially what it means. And then we have the next one is shuffled RDD. So a shuffled RDD is a RDD of key value pairs that represents a shuffle step. So we had a shuffle step when we use big data analytics, where all of the keys that are of the same sort are sorted when we are creating our final output. So basically a shuffled RDD implies that all of the values that are present inside the RDD are sorted by the key. So when we run dot sort by key on any RDD, for instance here in this particular example we're running it on a variable M, they are basically sorted in order. We can see we have our particular sequence, one which is mapped to a particular value, and then we have 5 which is mapped to a particular value, so on and so forth. So basically what will happen is when we sort this particular data, it will basically sort it in the order of the ascending order of the keys that are present within the data set. And then we have our pair RDD. So the pair RDD basically means that these data sets, these RDD are key value pairs, which are particularly helpful when we need to perform similar operations on keys, on each key. So for instance, here we have something like dot count by key. So what does that mean? So basically what we're doing here is we're running an operation where wherever there is a key, it is basically being counted, and how many, in what quantity does that particular key exist. So in here we can see we have 3, 7, 5, 4, and 2 as keys, and they have particular values that are mapped to those keys. So wherever there are values which are mapped to those keys, we see a 1. We see a mapped value which is 1 that is mapped to those keys when we run our .count by key. But in the case of 2, we can see that there is no value which is mapped to that particular key. So 2 exists on its own without any mapped value to it. So in our .count by key, we don't see 2. So that is because it has 0 values mapped to it. So that basically means that when we run the count by key operation, we get all of the pairs that are present inside of our RDD. When there is no pair and there is no count that is to be displayed for that particular supposedly non-existent pair, then it shows us the null value, which means that the value will not be showed in our final output when we run the count by key. And then we have our Hadoop RDD. So if we have our text file, if we have a Hadoop file or a sequence file for that matter, and we create an RDD using the Spark context, we can create an RDD out of that. So that would basically create a string value or a numeric value depending on the data type that is present inside of all of those files. We basically create an RDD out of the files that are already present or pre-existing in our disk. So we can basically copy that into our memory. And then we move on to the RDD operations. So basically we have certain operations that we can run on these RDDs. There are not a lot of functions, but there are certainly operations because we need to transfer this data. As you can see in the diagram, we can run a particular transformation on an RDD, and the action will occur after the transformation is run on it, and the value will be generated after that. So the thing about RDDs are that they are immutable because they are in memory. So they are present inside of the memory and they are not changed when we run a transformation on them. So basically what happens is whenever we run a transformation on an RDD, it returns a new RDD. So it is important for us to create a new RDD if we want to create a new RDD variable essentially if we want to store the new RDD that we created. Inside that variable, we can store the new RDD. If we try to use the same variable again in order to store the new RDD, it will give us an error because RDDs are immutable in nature. So transformations are lazy operations on RDD. So lazy means that they are in-memory operations because we are not essentially altering the current RDD. Basically, we can set all of these steps up before we actually run our RDD transformation. So Spark knows what to do with that data and how to do it. So then we have certain transformations, certain examples of transformations, which we're going to be discussing some of in our hands-on tutorial section that we have later on. So map, flat map filter, map partition. So if you're coming from a data analytics or data science background, some of these terms might be familiar to you, like union, intersection, distinct, group by, key by. Even from an SQL background, you might be sort of familiar to this. So in Spark, we can run these same operations on RDDs as well. Now that we know the basic implementation and introduction of RDDs and know that RDDs work in memory in a certain way and they execute when we actually call upon operations that call for their execution and not during the statements that we make which set up the execution. Now we can understand how RDD works by a tutorial. So firstly, let us start our Spark shell. You type spark -shell, enter. If you have your Spark installed, it will take some time to start up, and then we will see that the Spark has started with the sc context variable. So we can simply now create a list with a certain amount of partitioning. Call this val x equals sc.parallelize. So the parallelize option gives us a way to create as many partitions as we want for our particular data that we are creating. In our case, we are creating a list with certain string values. So the first will call Spark RDD example, any values that you would want. This is just to show you guys how simple it is. If you are coming from SQL or data science background to get started with Spark, sample example again. Then close this up. We can use the number of partitionings that I would want for this is, for instance, say 3, and close this up. And then when I press enter, our value X, our list, our RDD would be created. So as we can see, an RDD has been created of a string data type, and we can now go ahead and run new operations on this as well. So for instance, say I can run a map operation on this. So I can map all of these string values to a certain integer value. So say I want to create a new RDD, I'll call this Y, and I want to take X, and as I discussed before, create a new RDD out of X, because there is no way that we can actually transform X. We always need to create a new RDD and store it inside of a new RDD. So X.map, and that would mean that for every variable that is present inside this X, we can map a certain amount of a certain implementation for it. So say I want to map every variable that is present inside of the X RDD with 1. So I can simply type X, 1 and close this up. And when I press enter, all of the values that are present inside of X are now mapped with 1. So if we just see how this looks, so if we type in y.select to view our new RDD and press enter, so we can see all of the string values have been mapped to 1. So we have, we can call this a key value, and this is a value. This is a key, and this is a value, and they have been mapped together. So the mapping part of our operation, if we were doing a map reduce operation, has been done. So next that I would like to discuss is a filter operation. So this is like a or just a flat map operation. So what does a flat map operation do? So the difference between a map and flat map is the flat map converts even a multi-dimensional array into a single dimensional array, right? So let's see how does that work. So say that if we were running an operation such as this, sc.parallelize list, and create any list that you would want. I would create 1, 2, 3, a new an integer list with the values 1, 2, 3. And when I perform a flat map on this, simply type flat map, syntax sensitive, and the values that are present, the variables that are present inside this flat map, I would map them onto another list, a sub list, which would be x, x, and then perform a collect on this, so we can see what it looks like when I press enter. So as we can see, even though I'm mapping each of the values, that is 1, 2, and 3, to a list which should contain the values repeated thrice, it is not actually doing that. What it is doing is essentially creating a single dimensional array where the values that are there are occurring only three times. So that basically means that whenever we run a flat map operation on things, it basically doesn't create a nested array within that array. It creates a single dimensional array. So if we were running this for a simple map operation, if we just remove the flat from here and convert this into map, and then we press enter, so that would contain a sub list. So let's see how does that. So now we can see that for every x, when we are mapping it with a list, so what is happening is essentially all of the values that are present inside this list are being replaced by thrice repetitions of those values. That means 3 sub lists that are present within those particular value areas. So this is what the map does, and this is what the flat map does. So I hope that difference is clear. So now we can move on to certain SQL operations. So we have this where option in SQL, right? So simply we have a similar implementation in Spark as well. We call it filter. So say if we create a list, we can call this list, let's create a list from here, and it's a numeric list, so something like this. We call it numbers because we're going to be storing numbers inside of this, and within this list we can put in values such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then close up this list and create an RDD, which we will call numbers. So say that we want to filter out only the even values out of this particular RDD that we have created. We can simply create another RDD for this. We call it evens, and we'll put in something like numbers.filter. So that would filter out the RDD in the criteria that we would now write. So we will write underscore %2 equal 0. So once we do that and type in collect, it would basically filter out all of the values which has the modulus with 2 equivalent to 0. So whenever we are typing an underscore, that would include all of the values that are present inside of the RDD, and the modulus with 0 should be equal to 0. Modulus with 2 should be equal to 0. That is the criteria for even. If you've done programming before, you would understand that. And when we do collect, it would essentially show us all of the even values that are present inside of this RDD. So this could be any criteria that we would want. So if we could simply type in something like events, odds, so that would create something like, and we type in not over here, so that would give us all of the odd values as well. So as we can see, 1, 3, 5, 7, and 9. So all of the odd values that are present inside of that RDD are there as well. Type it like union. First we have to form a union, and then after we perform the union, then after that we will type in distinct over here, and that is how it will happen. So first we need the full entire RDD that contains both of the values, and then we need to form the distinct. So that would give us the non-common values that are present within both of these RDDs. So when we press enter, so we'll get all of the values that are not common within both of these RDDs, between both of these RDDs. Then obviously we can run something such as sort by. So how does sort by work? So now that we've created an RDD, we can simply type in something like this. We can use parallel for this, parallel dot sort by, and then give a criteria for the sorting. So something like variable C, true. Select. When we press enter, we can see that the original array that we had for this for the parallel was 1 to 10, and here we also have 1 to 10 as well. Then we can use something like zip. So zip basically combines two particular RDDs in a different manner as well. So how does zip work? Say for instance, when we were using union, so that combined all of the elements that are present within both of the RDDs. What zip does is something in a quite different manner. So how does this work? So we'll see that. Firstly, let's create one RDD. We'll call it zip1, and create a list within it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and press 9. We will create another RDD with list2, and create some other elements in this like 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. When we press enter, we'll create another RDD. So we'll create zip final and make it equal to zip1 zip, which is our RDD transformation statement, zip2. So when we do that, it will create our zip final, which is the zip version of both of these RDDs. We simply type in zip final.collect to see our output. So we can see that the values that are present within both of those RDDs are mapped to each other in such a way. Like 1 is mapped, like here we can see 1 and 11, they are both mapped together, and 2 and 12, they are both mapped together. So basically in the sequence of their occurrence, the RDD values are mapped to each other. So that is what we can do with zip. So these are some of the few examples, some of the few things that you can do with Apache Spark. So you might be thinking, what is so special about this? Why can't I do this with simple Python? You can certainly do it with Python, but the thing about Python is Python on its own cannot process large amounts of data. So as much as I am doing this right now with a very small amount of data, like numeric data set that we have over here, Apache Spark's special quality is not in the methodologies that it provides. It is in the overall implementation in the background that it provides, like the in-memory processing and processing over a distributed file system. So all of these things, processing over a Hadoop cluster. So all of these advantages are done in the abstract form by Spark. So you don't need to worry about the logic of it all. You simply need to focus on the big data analytics aspect of things, and not on the configuration, not on the distributed file system and any other aspect. So that is the main advantage of Apache Spark. So if you're interested in this, if you like what I showed you right now, you can simply try this on your own. Look at tutorials online, look at how to install Apache Spark. You can find it on our own website as well. You can basically, we'll guide you through the learning path of Apache Spark in just a moment right now.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. Data frame, C. Data set, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What are data frames in Spark? So now that we know what data sets are, data frames are essentially a data set organized into named columns. So data sets are essentially arrays that are unstructured in a way, and when you convert those arrays into a actual table, an SQL table, that table is called a data frame. So it is conceptually equivalent to a table in a relational database management system, for instance, a MySQL or an Oracle database. And it is also sort of similar with the data frames that we create in R and Python. So if you're coming from a data science background, you might be familiar with the data frames that are possible in R and Python as well. But Spark is obviously built for big data analytics, and that is why it is easier to basically analyze big data sets with the use of Spark. So as we can see in the diagram, the data set object, the JVM object, the dataset object was once transformed using the map, filter, or flat map function, whatever it was, into furthermore JVM objects. And then by using the simple 2DF function, which means the two data frame function, we converted them into a Spark data frame. So this Spark data frame has named columns and is essentially a very well structured format of data. So we can perform queries on this, SQL queries on this, and basically overall treat it as a structured data set. So the APIs available for Java, Scala, Python, and R. So the data frame API is available for Java, Scala, Python, and R. So if you're even from a Python or R background, you can still use Spark data frames very easily. So now we move on to the data frame tutorial. So I'm going to be using my Linux virtual machine to actually perform this. So let us begin. So currently we are inside our virtual machine, and we're going to be performing some analytics on a text file that I have created. So the text file is called YT Live. If I just open it up, the contents, we look at the contents of this text file. So these are this is the content that is present. So it says, hello from Intellipaat. Today we are going to be discussing Spark data frames. Hello from Intellipaat. So this is the content of the text file, and we're going to be performing some analytics on this. So the first thing that we're going to do is open up our terminal. So I'm going to just zoom this up so you guys can see clearly. So firstly, we're going to be starting our Spark shell. So type in Spark -shell for that. So that will start our Spark shell session. Yeah, so we have created our Spark shell. So right now, the advantage of Linux is it's pretty easy to install Apache Spark because we don't need a multi-cluster system to actually use Spark, and it's a preferred environment because if we are going to do this on Windows, then we'll have to virtualize the concept of a cluster, and it involves a lot of setup procedure. So it's always better if you can just get a virtual machine and then start to install Apache Spark. And then we can begin with our question. So firstly, I'm going to just create a variable to store our text file inside. So I'll call this RD, and I'm going to equate it to sc dot text file because we're going to be analyzing a text file. So we need to import a text file with our Spark context, and our Spark context variable is sc. And then within our brackets, we're going to be specifying the parameter or the address where our text file is. So just open up double quotes and type in the address. So in my case, it's home training and YT live.txt and then close. So I'm just going to verify whether it's that before I actually execute that. It's called ytlive.txt. Absolutely, it's correct. So now I'm going to begin. And then after that, just simply press enter and it will create an RDD out of that text file. So we're going to use this RDD object and then essentially create our word count program first. So simply create another RDD. We'll call this counts and wait it to rd.flatmap. As we were discussing earlier, we can further transform this RDD line. So line is a variable. You can use any variable that you want, but I'm using line to indicate all of the lines that are present inside of my RDD object that contains my text file as a string, and line dot split, and I'll split this line on a particular regular expression. So this regular expression in my case would be double backslash w plus. So what does this mean? So this expression essentially implies that all of the special characters and numeric values present within our text file will not be included in the final data frame that we will create. So it will only give us the pure words, because we are going to be performing a word count, and then we are going to convert that word count RDD, the count that we receive, into a data frame, a structured data set. So that is why we're using a double backslash W plus instead of an actual space as our delimiter. So once we are done with that, dot map word, and word is another variable that I've created to indicate words as opposed to lines, and then every word I'll map it to 1. So every word, whenever it occurs, will have the count 1. And then I'll close this up, then type it reduce by key. So map reduce. I'm going to reduce all of these words mapped to 1. Whenever they occur, I'll add all of their values, which is 1. And then given the parameter that I want for this, which is plus sign, because I want to add all of the key values. And then press enter. So that creates another RDD, which, as we can see, contains a string element and an integer element. So the string element is the word, and the integer element is the count associated to that word. All right. So now we will actually create a data frame with the simple 2df function as we discussed. So we'll call this variable df, and we'll convert counts to df, right? Because we need to convert this RDD, this object, this JVM object into a data frame, and press enter. So the 2df successfully converts our RDD into a data frame. So on one column, we will have all of our words. On another column, we will have all of our counts. So we've created it successfully, and now we will now perform some operations on this. So the first thing that we can do is change the column names. So currently, we have _1 and _2 as our column names. If I simply type in df dot show and press enter, then we'll get our table that we have. So as we can see, the column names are _1 and _2, but we need to change these column names into something else. So for that, simply type in another, we're going to create another data frame. We'll call this df2, because you cannot actually change something that is already present. You cannot change an existing data frame. You cannot transform it. You'll always have to create new data frames or new objects, because Spark functions in memory. So whenever you're doing something new, you will create a new copy of that inside of the memory. All right. Okay. So df dot, the new data frame would be equivalent to df dot 2df, because we're going to be converting this into a data frame again. And the sequence of the column names would be word, comma, count, because this is the sequence that I want my column names in. So I'm creating a sequence for that. And then I'm going to replace this, replace the existing column names, which is underscore asterisk, with this new sequence of word and count. So how does that work? It basically means that underscore asterisk represents both underscore 1 and underscore 2. The asterisk is replaceable with 1 or 2. That is what it means. If you've ever actually dealt with the Linux file system, you will understand that concept. So the word will replace the first, which is our underscore 1, and the count will replace our second, which is our underscore 2, and we will have new column names in our new data frame that we are creating, and we'll press enter after that. So we've successfully created two new column names in our new data frame. So if I simply type in df2 dot show and press enter, so as we can see, the column names are different in this. The first column name is word and the second column name is count, right? So let us do some transformations, or let us do some querying on the data frame that we've created. Now that we've successfully converted an unstructured data set into a structured data set, which is this word and count, proper SQL table, right? So now we can perform some queries on it and see how that goes. So as if you remember, in SQL, we have something called order by. So if I simply type in df2 order by, and if you want something like ascending order, right? If you want all of these counts in ascending order, you can simply use ASC for that. And given the column name count, dot show, and given like we want the first 5 counts, so do that and press enter. So we can see it has been arranged in ascending order. So if we just see this in ascending order, we have a lot of ones, so that will arrange automatically. And that is how we are getting a result. The first 5 results with 1 is what we are essentially getting. And if we want to ascend it, arrange it in descending order, we can simply type in BESC and count, and that would arrange it in descending order as well. So as we can see, the counts have been arranged in descending order too. Data frames also provide us with the filter function, so we can use that as well. So to filter out particular column attributes, if you simply type in df2.filter and given a criteria inside of double quotes, so I'll say count has to be greater than 1. So this is my criteria for the filter. So that's the query that I sent in the function's parameters, count greater than 0. So that would go into the SQL context for this data frame, and type in dot collect, and bracket open, bracket close, press enter. So that would essentially give us all of the elements present within our data frame that are above the count of 2. So we can also do it this way. If we want to simply see it as a data frame, remove the collect and type in show and press enter. So that would show it as a data frame. So this was showing it as an actual SQL row, but here it is showing it as a data frame itself. So you can use collect and show alternatively, depending on the use case that you may have. If you want to send data, then definitely use collect. If you want to display data, then use show. All right. So these were some of the functions that you can use with data frames. There are obviously a lot of functions that are possible because it essentially gives you the option to treat big data as an actual RDBMS table.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Let us now get on to how to access data files. So I'll be showing you a brief hands-on on how to access the data files, and then we'll eventually move on to querying the data files. So accessing a data file is actually quite simple. Simply create a document first, right? So you can do this with the command line as well, but I'm doing it with some visual interface just to tell you guys how it actually works. So let's call this example.txt, right? So once you've created that, you can simply open it up and type anything you would like. So in our case, let's just type hello from Intellipaat. So this is basically a data file, right? This is unstructured data in a way. There's no order to it. It's just a basic sentence. So if you want to convert this into a Spark JVM object, you'll simply save this first, right? Close this up. So this is also the present working directory that we have. So here is the file. Simply open up a terminal. So this is a terminal. I'll just expand the size for you guys so you can see. Yeah. So there. The first thing that we would do is obviously start the Spark shell, right? So the Spark shell by default starts in Scala. So it is a Scala shell with the Spark libraries already imported. So it takes a bit of time to start up, but it starts up. Yeah. So the Spark session is available as Spark, and the Spark context is available as SC. So this is a variable that we would be using to invoke the Spark context, right? So the thing that you would do is create a variable. I'll call this RDD, right? And equate it to the sc.text file. And given the location for where you want to take your source file from. So in our case, it would be from the present working directory, which is home training, and the file name, which is example.txt, given the double quotes again, and close it up and press enter. So that would create the RDD out of that particular text file. So that is how simple it is to basically take a raw text file or a raw data file and convert it into a Spark RDD. So now we have reached the querying part. So let us see the exact procedure that Apache Spark follows for this data file querying. So as we can see, the way we achieve data querying is by converting the raw data that we have. In other words, the data files that we were referring to earlier. We basically convert them to data frames, and then we run normal SQL queries on them. So the definition of a data frame is it is a data set organized into named columns. It is conceptually equivalent to a table in a relational database or a data frame in R Python, but with richer optimizations under the hood. So to explain that in brief, it basically means that Spark data frames are equivalent to SQL tables, right? The relational database tables, or you could basically equate them to data frames that you would normally create in R and Python with vanilla R and Python, mind you. So it is basically equivalent to that. But the richer optimizations here implies that it is optimized for cluster computing. These are not normal data frames that are present within one system. These data frames could be present throughout multiples of systems on multiples of nodes in a cluster. So, and you wouldn't even notice the difference. You are just seeing it from one point of view where you see the entire data frame in one page, right? So that is the difference between a normal data frame and a, say, R/Python data frame, right? So the procedure here, as we can see, raw data, which could be semi-structured, unstructured, or even structured at times, data, it's first converted into a Spark JVM object, right? So there are essentially two types of Spark JVM objects. Spark obviously uses JVM objects because it is an object-based framework. So one of them are RDDs, and the other is data sets. So you can basically convert them into JVM objects, the data that you have. So these could be arrays and whatnot, right? So once you have these arrays based out of the raw data that you've generated earlier on, you can convert these arrays into named columns, and those named columns are then called Spark data frames, which is our target anyway, right? So once you've converted them into Spark data frames, which are SQL-like tables, naturally you should be able to run SQL queries on it. And Spark actually allows you to do that because Spark provides the SQL context, which means you can pass string values, which are equivalent to SQL queries that you would normally pass in, say, MySQL, and then basically analyze the Spark data frame that you have like an SQL table, and then get your query results as is. So that is how much Apache Spark simplifies analyzing big data. It brings it down so that a normal person who has experience in relational database management systems can use Apache Spark very conveniently without having to learn a lot of new things, right? So these are one of the advantages of Apache Spark, the accessibility that it provides, right? So as we can see on the bottom, Spark SQL context is created to run string-based SQL-like queries on Spark data frames. So as we discussed earlier. So now let us perform some SQL queries using the SQL context that Apache Spark provides on a freshly created data frame. So let us begin. So now let us take an example at a real life data set. So we'll be looking at a comma separated file, a comma separated value file, a .csv file. So this is yellow.csv. So what does yellow.csv have? So in order to give you a brief introduction to the dataset, it's basically a taxi dataset, like a taxi trip dataset. So you have your pickup date times and your drop off times and the total duration of the trip and the total distance of the trip, where the passenger was picked up and where the passenger was dropped off. So all of these things basically, and the distance between all of the trips and the amount, the fare and everything. So you can think about this as a taxi data that has been generated for the well-known taxi apps that you may be using on a regular basis. Well, not these days because of the virus, but in other ways. So Ola and Uber sorts. So this is basically the data that they're generating on a day-to-day basis. So if you just scroll down, we can see that this somewhat qualifies for a big data use case, right? And we're going to be actually running some queries on this data set. So firstly, this is in a semi-structured format, a CSV file. We are going to be converting this into a data frame before actually performing queries on it, right? So let us just quickly minimize this, or you can just close this off as well. Works the same. And open up our terminal, right? So let us continue from where we left off. So open up the terminal and expand this, right? So firstly, we are going to be actually importing our taxi data set, which is the yellow.csv. Right? So let's create a data frame out of that. So we'll call this data frame df and simply type in Spark, which is the Spark variable that has been created, the session variable, dot read, and that then will give a simple dot format and specify the format of the file. In our case, it's a CSV file. Type in CSV for that. Close that up. Now you can give certain options to this. So we'll firstly give that we actually want the header. So the header is the first row that is present in each CSV file. So we want the header to be there. So we will simply give an header as true. We'll give some other options as well. We want this to be treated as a schema, so we'll do that as well. So this is a simple option for that. And for schema, we'll give this the Boolean value of true. Right, and then simply type in another option. You can keep on typing options, as many options that you would like. So you can Once you would actually start to understand Spark, you'll understand how many options there actually are. And given a mode for memory management purposes, so I'll give this a fail fast mode. And then simply type in the location of the file. So type in .load and given the location of the file. So in our case, home training yellow.csv, and close this up. And once you do that, it will automatically create a data frame out of that CSV file using the comma separated value functionality, and press enter. So it takes some time to load it all up. So, but once it loads it up, there's no delay and latency after that, because it is essentially loading it up inside of the RAM, right? So let us now continue with this. Firstly, we'll actually not call this the DF. We'll create a temporary view out of this DF so we can refer to it in the SQL context that we would invoke later on. So we would be renaming this table essentially and not calling it DF. This is an optional step, but it's for better readability of code. So it's always recommended. So create or replace temp view. And you can call this anything. In my case, I'll call this taxi data, and then close it up. Press enter, and it will create the new view, right? So after, we are basically referring to it as taxi data from now on whenever we use the SQL context on this particular data frame, right? So say now we can run some queries on it. So let's think of a query. Say we want to find out a total number of trips that have been taken throughout the data set, right? Simple. Simply invoke the Spark session variable, type in .sql. So we are now invoking the SQL context as well. And it's simple as anything. You can simply start a string value or double quotes and type in what you would normally type in MySQL, right? So how would you do it in SQL? Select, and then you will type count. Count is a function in SQL. And star, so you want to count all of the records, so you're typing in star, so all of the rows, basically the number of rows will be counted except the header. And type in from, and the alias that we just provided it earlier, which is taxi data, we'll call it taxi data, and simply double quote close and close this up. And what this will do is basically, and when you type in .show, this will show you the result out of that SQL query. So you will get what the MySQL would have shown you normally. So in this case, for big data, press enter, it will give you the count, right? So in our case, we have about a 10,000 number of records, basically. So we get that. Now, say we want to get a little more complex, right? So now we want to find out the total number of the total revenue that is generated, right? So the total revenue that would be generated from all of this would be the sum of the column, that is the revenue column. So if we just simply see how this is working, if we type in df.show and type in 3, so we want to see 3 records to get an idea of how the columns are working. Press and enter. So as we can see, the record that we want to refer to is the total amount, right? So this is the amount. So this particular column, we want to add up all of the values in that and finally get the value at the end of it that we would like, right? That is what we want to do. So let us just simply do that. So we know the column name that we want to refer to. So if I simply type in spark.sql and type in select sum, and then type in the column name that I would like to use the sum for, which is the total amount as we saw in the column name, right? From the temporary view, which is taxi data, close this up, press enter, and it will show you that. So actually I didn't type in show. If you simply type in show, it will show me the actual output of that, and press enter. So now as we can see, the total amount, the sum of the total amount is about $160,000 or rupees, whatever the amount is in. That is irrelevant at the moment. But yeah. So say if we want to actually do something else with this. So say we want to find out a particular fraction, right? We want to find out how much is out of this total amount that we have, the total amount that we've calculated, how much out of this is toll revenue, right? So that is also simple. Simply type in spark.sql, select sum of the toll amount. So here's the tolls amount that we have. So it's TOLLS_amount. So it has to be exactly that. So the total amount of toll divided by the total amount of total amount, right? So we get that, and out of the taxi data. So this will give us the value that we require.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and data frame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
Type in .show after that and press enter. So as we can see, the fraction that we have is about 1.5%. So as we can see, it's about 0.015. So that is the fraction basically about with the ratio of the toll amount and the total amount basically. And from here on out, it's basically simple SQL. So now you know you only have the only Spark aspect that is coming into it, as we had discussed earlier before. If you're coming from an RDBMS background, the only new thing that you really have to type is this spark.sql. The rest of it is basically the same. And if you want to take out the average amount for each of the trips, you can simply type in select and then type in AVG and given the column name that you want to calculate the average of. So AVG is also a function that is present in SQL by default and given like from taxi data. Close this up and type in .show. So this will give you the average amount. So the average amount for each of the trips is 16 units or $16. And if you want to get a little more complex than that, so say if you want to use the group by clause that is present within SQL, you can use that as well. So if I simply scroll up, we can see that there's a payment type, right? So the payment type and the data description is basically in categories like 1, 2s, and 3s. So all of this is there, right? So if we want to arrange particular results according to the payment type, we can do that as well as we would do in normal SQL. So if we type in spark.sql, say we want to arrange the average, say the average, any column name that we can pick up right now, the fare amount, say if you want to pick up the average fare amount that we're picking up, right? And we want to arrange it by the payment type. So the payment type could happen online, offline, like you pay cash. Sometimes you use online wallets. Sometimes you use cards. So basically all of those things have been mapped to particular numbers like 1s, 2s, and 3s. So that is not relevant to us right now. What we want to do is basically arrange it according to the payment type, right? So simply type in select the payment type, because you need to select the column name that you are grouping the entire query by. So the payment underscore type is the column name that you absolutely want in your result. And then simply type in the average of the fare amount. So the fare underscore amount, it has to be the exact column name that you're using. And then what you could do is simply use from taxi data, but that doesn't end there. You have to also group it by payment type. So at the end of it, simply type group by payment type, close this up, and put a dot show at the end of it, and then press enter. So that was actually an issue because we mishandled the column name. Simply type in an underscore after that because that is the actual column name, and then press enter. So as we can see, there are basically 4 payment types that we had, 1, 2, 3, and 4. So all of these could have been mapped to anything. That is not relevant to us right now, but what we know is for each payment type, we have gotten the average fare amount, right? So we can use group by as well. And if you want to go into even more complex territory, we could take a query like which hour of the day on average makes the most amount of revenue, right? So the way we would go about that is simply invoking the SQL context once again. And here we're going to be making a nested SQL statement. So if you're familiar with SQL, you would understand this. We're going to be using aliases in this. So say the first alias we would be calling h24. So h24 would be what our nested SQL query would be. And as R, we also need the average of the total amount for this. So make sure all of these names match. So we're also assigning an alias to this, which is average revenue from, and this would be the nested SQL statement. So this is also a select statement inside of this. Select R, the pickup date time. We'll just look at the column name for once. Just simply scroll up and look at the column name. What is it actually called? The pickup time. So we have the tpep underscore pickup underscore date time. Simply copy this, right? So copy this, and once we scroll down back, erase this and paste it over here. So we have our pickup date time. So this is basically the pickup time of when the trip started, right? So we actually entered our pickup time. Close this up. And refer to this as h24, which we were referring to before over here, right? So our pickup time is h24. The total amount involved in this for each particular hour, basically each particular pickup time, from taxi data. So first thing that we would do is obviously group it by h24. And order all of this. So basically ordering means sorting all of the results by the average revenue, which is the alias for the average of the total amount. And if you don't specify the DESC right here, then it'll basically order itself in the ascending order, but we want the highest revenue that is generated. So we'll arrange it in descending order. So we get the first result first, right? And then simply close this up and type in dot show and press enter. So as we can see, the R number 22 has the highest average result, average revenue. So the 22 would basically imply the 10 p.m. mark. So in the 24-hour clock, in the 10 p.m. mark, we have the highest revenue, right? So that means 10 p.m. In this particular taxi organization's business, 10 p.m. is the most profitable. So that is basically what the average big data use case statement is. So you'll be asked by your employer to basically calculate these particular insights. So say now that you have that information, you know that you're going to be encouraging your cab drivers to be really active around that time, the 9, 10, 11 p.m. mark, because that is when you get the most revenue and the most profit out of it, right? So out of that. So as you can see, it is simply arranged in that order. 0th means the 12 a.m. mark, the 23rd means the 11 p.m. mark, and the 22 means the 10 p.m. mark. So these 3 hours are the most profitable in that particular order, right? So this is basically what you can do with Spark and the Spark SQL context. And by converting normal unstructured or semi-structured data formats to a data frame and simply running what you would run in an RDBMS system, but for big data.
We will be working on kind of like a real problem, crimes in Chicago, right? So the first thing that I want to talk about here is that this particular problem is taken from a certification exam. So I think an year back in the Cloudera certification exam, they asked this question. Okay, not the exact question, but very similar. So what I thought is like I'll take a question like that, so you will also understand. In case if you're writing a certification exam, how the questions will be. So people ask. So this is how almost a question will be. And also it is a real data set, a real case study. So that also will be interesting, right? And so imagine that you're writing a exam, certification exam kind of thing, right? So they will give you a problem statement. That is how they do. They give a problem statement, then they will give you a cluster, they will give you the data, everything, and then they will ask you to solve it, right? So that is how it works. Now, the original data for this problem is actually in 4 files. You can see here. There is Chicago crimes 2001 to 4, 5 to 7, 8 to 11, and rest of the data. So the original data is approximately 2 GB. I don't want to use the original data. I want to use this last file called crimes.csv. So basically, these are the crimes reported by the Department of Police in Chicago from 2011 to 2017. And let me show you how the file looks like. Even though the file has many columns and many things, it's a very rich data set. The questions requires us to work only on 2 columns in this particular problem statement, right? But maybe you guys can use this data set to explore further, because like I said, it is a very rich data set. I'll show you what is in the data. So let me open the data set first. So the size of this file is close to 400 MB. And that is why Excel has a trouble reading the file. It will read partly. It cannot read the complete file because the size is a little bit big, right? So it's almost open. Let it open. I'll show you what is in the file. And in certification exams, what happens, in case if you're interested, we will discuss this later regarding certification. But to give you a small idea, what happens is that if you go for a Cloudera certification exam, right, on Spark or anything like that, they will give you like around 2 hours, and they will give you some 8 questions to solve, practical questions. There are no multiple choice questions. It's all hands-on, right? And ideally, if you ask me, I don't want you to write the certification exam. That's my advice, because Cloudera suggests that people should work for at least a couple of years before attempting the exam, right? Exams are tough, to be honest with you. It's not very easy. So if you directly complete the course and write the exam, you will find it very difficult to handle the questions, right? But anyway, you can probably after a year or something, if you get a chance to work, you can definitely write a certification exam. Now this is the file, crimes in Chicago, and this has many columns. Okay, so there is an ID column, there is a case number. We are interested in this column called a date. Okay, the date column. The date column is very interesting. because why it is interesting, you have like, the actual date 5/3/2016. So that is like the month, day, and year. And then you have the timestamp 2340, etc. There is an AM PM as well. I don't know why it is not reading in the data set. There is an AM PM as well in the data. I don't know why it's not getting displayed. So the point I'm trying to tell you is that the date column is kind of like completely unstructured, because you have, first of all, backward slash for month and all, then you have column for hour, minute, second, and all. So we are interested in the date column. That's one thing. Then there is a block, IUCR code. And the second thing we are interested is this primary crime type. So each line in this file is a crime. So what kind of a crime is it? Battery, public peace violation, theft, motor vehicle theft, robbery. So we are interested in this as well. So these are the two columns which we are interested for our problem. There are many other columns you can explore. I will share a document which explains what is what. Don't worry, right? So, and then there are many lines of data. So we have close to 1.5 million lines of data in this, which is good, right? Close to 1.5 million. So this is how the problem statement is going to look like. If you go for an exam, this is how the problem statement is going to look like. So they will ask, choose language of your choice, Python or Scala. So it doesn't matter which language you are using. The data is available under certain location. They will give you the location for the data. And they will say you can check the properties of the file by running a command. And they will say the structure of the data is like this. These are the columns you have in the data. File format is text file, delimiter is comma, and this is the problem statement. Get monthly count of prime crime type sorted by month in ascending order and number of crimes in descending order. I will explain the problem statement later in detail, but that is the problem statement. Then they will say store the result in your HDFS path. They will give a location where you have to store the output of your program. The output file format has to be text. Output columns, very important. They will say that in the output, they want 3 columns. You need a month column that is in YYYYMM format, crime count, crime type, and the output delimiter has to be tab. So this is your entire problem statement. Now I know that for people who are very new to this, it will take at least half an hour to understand the problem, because it's not straightforward, right? If you sit for an exam, it is not straightforward. It's very confusing actually, right? And you will have trouble understanding the problem itself. But I will explain the problem. What I wrote here is not part of the business problem. This is something I wrote to analyze it. Don't worry about this, right? But this is something I wrote myself. This is actually part of the business problem. Okay, fine. So now let us see what they're asking, right? So, okay. So from this data set, what I did is that I just took some sample data to make you understand. First of all, this is the problem statement. Get monthly count of primary crime type sorted by month in ascending and number of crimes per type in descending order. Okay, fine. Output columns, month has to be in YYYYMM format. So our first challenge is we need to get the month in this format, YYYYMM. So I have taken a simple example here. So imagine from the data set, you extracted the data like this. For example, so this is how you're going to extract. So let me just write it so it's easy for you to understand. Control C, Control V. and again this one, Control X, Control V. So this is 2007 07. Just hold on for a moment. I'll explain what it is. Okay, don't worry. 2007 03 X, 2007 02. So your first challenge is that even without understanding the business problem, you can understand that they are looking for month in YYYYMM format. This is your first challenge, because you know the data looks like this. If you read the data is like this. It has, let's say, the month, which is, let's say, 05 slash the day slash, let's say, 2007. Then there is a hour, minute, second. So the data, and then there is an AM PM. So the column value is like this, right? I don't want this. I want to convert this in YYYYMM format, right? That is your first challenge. And imagine somehow you are able to do it. Okay, so what you will be doing, from each record, from each line of your CSV file, you will extract the month, and you will somehow calculate the number of crimes happened in that month. So it's sort of like a word count. So let us say you're talking about 2007 January. So in 2007 January, so this is 2007 January, right? There can be a crime type called battery, and you collect each battery crime, and then you do sort of like a word count with the month as the key, battery as the value. You figured out that there are like 300 crimes related to battery, imagine, right? And then again in 2007 January, you figured out that there are 200 theft crimes. Okay, fine. Then you land in 2007 July. In July, 100 theft is there, 50 robbery is there. And then you land in March. In March, 300 robbery, 400 theft. Then you land in February. In February, 100 rape, 500 theft. So your first challenge is, from the original data, you have to get only the year and month, okay, and the number of crimes happened. Once you get it, now your problem is, the business problem says, you have to sort the data by month in ascending order. Okay, what do you mean by month in ascending order? See, if you look at here, it's fine, because you are having January. After January, you are getting July. It's okay. But after July, you are getting March. This is not good. After March, you are getting February. No. So I want like January, February, March, July. First challenge. The first challenge is, you have to pick up only the year, month, and also year. So because there is multiple years of data, so after 2007 you should get 2008, and in 2008 Jan should come first, right? Because that is how people want to read the data, right? If somebody is looking at crime data, they want to read it in an order, right? Yearly order, monthly order. So first problem for us is that we have to sort it based on year and month. We are not done. Then they say sorted by month in ascending order and number of crimes per type in descending order. So what does this mean? So if this is your data, I want the output like this. Again, 2007, 01, this, and again here, 2007, 02, this, here, 2007, 03, I think this, 2007, 07, this.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. Data frame, C. Data set, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this data set, the output has to come like this. That too, it has to be tab delimited. I'll tell you how the output will look like. So it's easy for you to understand. So I'm going to use what? Tab as the delimiter. That is my problem. Now I don't want to use tab, but that's what the problem says. Battery 300, theft 200. This is your final output. Meaning, if you look at the final output, what you see is that, first of all, look at the first column only. The first column is sorted in ascending order: January, February, March, July. And within each month, the number of crimes are sorted descending order. Look at January. Battery comes first because 300, then 200. Look at February. Theft come first because 500, then 100. March, theft come first because 400, then 300. But the original data is not like this. That is what I want to tell you. If you look at the original data for March, this is March. In March, the original data says robbery is coming first, then theft is coming. Line by line if you read. Now I don't want that. I want theft to come first within March because top crimes are theft. Why? Because anybody who want to look at crimes, they want to see like this. If I'm looking at January, I want to see the top number first, right? Battery is number one. I don't want to see the bottom crimes. I want to see the most happened type of crime. So your final output of our today's problem should have 3 columns. They should be tab delimited, and the first column should be month, second should be crime type, third should be number of that type of crime. Month has to be sorted ascending. Within each month, crime type descending. So I'm going to go to my lab. I'm going to connect with the lab. Everything can be done from here. It's very easy, very straightforward. And I have already uploaded the data in Hadoop on my cloud lab. There is a folder called Raghu. Within that folder, we have the data. So the data is already uploaded. And I want to start the Spark shell. So the solution is here. And since we are dealing with kind of like, how do I say, a slightly bigger data set, what I want to do is I want to start the Spark shell, and I have to say master yarn. So normally you do it in the local mode, but the problem with local mode is like you're getting single executor, the amount of memory is less. I don't want to do that. So I'm going to say master yarn. I'm going to ask for 2 executors, and each executor will have 1 GB RAM. So total you get 2 GB RAM and 2 cores. Okay, so let's start it. Let's see whether it gives us resources. First of all, looks like we are going to get resources. And CloudX Lab is running the Spark version 2.1.1. That's fine with me. Any 2. Version is okay with me. They are running 2.1.1. We got the resources. Spark started. See, the version is 2.1.1. And what I'm going to do, the first step is that I'm going to read the data. Anyway, that's required, right? And when you're creating RDDs, do not say A, B, C, D. Give a name for the RDD. So I have given a name called crime data. Crime data is the name of my RDD. So if anybody look at my code, they can understand what I'm doing, right? So this basically contains the crime data. And I'm going to say I'm reading this file called crimes.csv. Now let's see whether it is able to read the file. I can do a crime data doc take 5, and I can say for each println. So take will show you, take is an action. It will show you the first 5 lines. I'm saying for each println, so it will print it line by line. Okay, so we are able to print. So the data, we are able to read the data. There is only one problem. It is also reading the header. This is the header, So the data contains header, and our RDD is also reading the header. I really don't want the header. I will show you how to get rid of the header. Okay. But let's also verify how many lines of data we are having. Crime data dot count. Okay. So when I call an action called count, I can see that we have around 1.4 million lines of data, which is nice, So, okay. So we have data. The first challenge is to remove the header. If I do a crime data.first, I can see that the first element of my RDD is header, right? I don't want the header. I want to get rid of it. See, there is things like FBI code and all. It's it's proper data. Community area, FBI code, all these things are there. Okay, so how do you get rid of header? It's rather easy. So you can create a variable called a header, first of all. So I'm going to create a Scala variable called a header by reading the first line of the RDD. So this variable called header will have a string value that is nothing but the first line of my data, header data. And now I can use a filter to remove this header from the original RDD. Let me show you. I'm going to create a new RDD that is called crime data without header. So you see the name of the RDD. I'm giving sensible names. I'm not saying A, B, C, D. This will even help me if I want to troubleshoot my program. If I look at this RDD, I know this RDD is the guy without the header because I have named it as crime data without header. So I'm going to say that crime data dot filter. I'm going to filter, and usually you say X, right? So normally when you write an anonymous function, you will say X, then rocket symbol. But here I'm saying criminal record. So each line is what? A criminal record. I can very well use X, but this will be more appealing. So if somebody look at my program, it's easy for them to read. So I'm going to say that take every line. I'm going to filter the data, take every line, and I want all the lines which are not equal to header or not matching with the header. So what Spark will do, it will run a filter transformation. It's going to compare each line with header, and it's going to keep only those lines, which are not matching with the header variable. So basically you will eliminate the header. Now let's look at the RDD, crime data without header. So if I look at this RDD and I will say I want to take 5 dot for each println. Yes. So the new RDD called crime data without header has, this thing gone. The header is gone. We are happy. So we have only the data now. So that is your first step. So Monangi says how it will know that it is header. It doesn't know. I've stored it in a variable, right? Monangi, see, look at here. I'm storing it in a Scala variable. So header is just the name of the variable. It can be Raghu very well. It can be anything. So I'm matching the content of this variable. Header is a variable, Scala variable. Okay. I'm matching. So when I say not equal to header, this header that you read here is this variable. Okay, and this variable contains this data. So basically it will match every line with this data. That is what is happening. Okay, so we got an RDD called crime data without header. So what is our challenge now? The challenge now is I want to extract the date column. I want to extract the date column. So when I say crime data.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Without header dot first. So I'm just typing crime data without header dot first. So you are getting one line of data from the original data. And look at the date field. This is the date field. So it says 3rd May 2016 backward slash. Then you have a space. Then you have the time with colon as delimiter. Then you have a space. Then you have AM PM. So I don't want all of this. I just want only the YY MM from this, right? So that is our requirement. The problem statement says, give me YY MM. So what we are going to do, we are first going to read this data and store it in a variable. So I'm going to say crime data without header dot first. That is nothing but the first line of your data. You're going to read it and store it in a variable called rec. What is rec? Rec is nothing but a string. It's not an RDD. It's not anything like that. Rec is nothing but a simple Scala string, but that contains one line of your data. It has one line of your data. Now, usually if you want to develop a logic, what you do is that you take one line of the data and develop the logic. Then you use map transformation to apply to the whole RDD. Do not directly work on the RDD because you know the RDD is pretty big in this example, right? So what I did, I took one line of data and I'm going to develop a logic on this line of data, right? And what is the logic? So you should also understand what the logic will do, right? So my logic says that from this data, so I will definitely extract what the YYYYMM part, then I will get the crime type. I will also get the crime count. End of the day, I will do sort of like a word count. I will get a crime count also. So if this is your data, 2007, you have in 2007, 01, and then you have, let's say, battery, and let's say 300. Then you have, let's say, theft, and let's say 200. I want to convert this into this format. So how do you know that this is the format you have to convert to? It has to come with experience. You may be wondering, okay, why are you converting this into this format, right? How do you differentiate it is string or RDD? If you look at here, it will show you. For example, the name of my variable is rec. If I type rec, just rec, it will say it's a string. It will simply show you it is a string. But crime data, we have created crime data. If I just say crime data, it will say it's an RDD. So if you simply type the name of the variable, it will show you whether it is string or it is an RDD, right? It's very straightforward, right? And how do you technically know if you call an action? If you call an action on the RDD, the output is not an RDD. That's the rule. Any action you call an RDD, the output will be an integer or a string or anything that you can save it, usually a string, right? Okay, so now if you look at this, my requirement now is, if this is the data you have, let's say in January month, you get battery 300, theft 200, etc., etc., right? If this is what you are getting, I want to convert this into a tuple format, this format. The tuple will basically have your year and month, okay? So if this is your data, what will happen is that I want to convert this data into a tuple format. And in the tuple, I will have the key as your 2007-01, and the values will be sort of like this and this, right? This is what I want to do. This is the whole date column, right? I don't want this whole thing. First of all, I want only this part. So how do you get this part? It's very easy. Let me show you. First of all, I'm going to say that I want to split this string based on comma, because you know this whole string is having comma as a delimiter. So I'm going to create an array called R, where I will store this whole string divided by comma. Why am I creating an array? So that I can access individual elements. So now I have an array, and in the array, I have all these individual elements. Okay. And the name of the array is what? R. The name can be anything. From the array, look at what I'm doing. From the array, I'm accessing the fourth element. What is the fourth element? First element, second element, third element, fourth element. This is the fourth element. From the array, I'm accessing the fourth element. Again, from this, I'm splitting it using space. So if I have to show you, if I get only this R3, you will get the whole thing, you know, the date, the time, the AM, PM. I don't want this, right? So what I do is that I say Further, split it using space. So when you split it using space, this will be 1, this will be another 1, this will be another 1. And then you say, give me only the first element. That is the date part. If I hit enter, this variable called D will have only the date part. Okay. So what you do, you say that I want the 4th element in the array. From that element, again, I want to split it using space. From that, I want the first element. So basically, you get only the date in this format, 5/3/2016. But what is your problem? You are not happy because I don't want the date in this format. I want the date in YYYYMM format. What is this format? So this data has to be like 2016-03. But my format is difficult now. It is like 5/3/2016. Right? So I need to convert this data now into 2016-03. How do I do it? It's rather simple. All I need to do is this. So have a look at what I'm trying to do. I'm going to say that I want to split the data using backward slash. So when you split using backward slash, what will happen? You get individual elements. Then I want the third element. So what this will give you? This will give you only 2016, right? And if I say I want d dot split, okay, and then again you say backward slash, and the month will be the 0th guy, this will give you 5. So we are doing a lot of slicing and dicing, I understand, and that is required. So from this entire date column, I split it using forward slash, and I'm asking, give me the last part, that is a year. Again, I split it using forward slash, give me the first part, that is a month. If I do it in a single line and concatenate it, you will have the complete thing. So I will say, give me the last part plus give me the first part, concatenate it, you have 2016-05. So look at this whole piece of thing. All we did is some slicing and dicing. But end of the day, the data we extracted first, only the, what you say, month, day, year part, right? And from this, we extracted the year and month and concatenated so that we have 2016-05. So this is the logic to get YYYYMM from the data. That is your first task, right? I hope all of you understand this because it's not that difficult. It is only basic slicing and dicing. However, we are not done because we are extracting only the date. We also want the crime type, battery, robbery, or whatever it is. So what I want is that I want the data in this format. So what am I trying to do? This M will have your, what you say, month. The variable called M, which we just created, will have your month. I want the data in this format where I need a key value pair. So what I'm doing here is that I'm converting M to integer. Then R of 6. What is R? R is our first array where the whole data is. And the 7th element in our data is crime type. So that is like battery, comma 1. Why am I representing my data like this? Because I want to do word count. See, if battery is repeating in 2016 May, I can easily do a word count, right? Otherwise, how do you know how many battery crimes happened in May? If I want to get a total count of battery crimes in May, I need to create a key like this. This key is kind of like a composite key. It has month and crime type, but for each record, I'm calling a 1. So if I do a word count on this, I can see if it is battery, if it is repeating 3 times, it will do a word count. I can see in 2016 May, 3 battery crimes have occurred. This is your half part of the problem. So half part of the problem is doing this, and I can do the whole thing in a single line. That's what I want to show you. So once you develop your logic, ideally you should write the whole thing in a single line. I'll show you R because not R, I'll show you rec. So we first start with splitting our rec based on comma. Then from there, we get the fourth element, split it using space, extract the first element. This will give you the date part. From there, again, I concatenate to get, let's say 2016 May. Finally, I represent like 2016 May battery, comma 1. This is your first task, or I can say half of the task. 0 refers to first element. So when you are accessing elements in the array, remember we had this Scala collection class, arrays, list, and all. So 0 basically refers first element. Okay. And also it sometimes I guess, in my opinion, you might have to run it by yourself to understand it. Well, I can show you this, but I'll share the piece of code. Probably you might have to sit for some time to run it step by step and understand what it is, right? So right now we have a variable called a t, and if you look at how I created this t, I will get the output in this format. But we are playing with only one line of data. We are not playing with the RDD. So I want to apply this logic to my RDD. So how do I apply my logic to RDD? Very simple. I can call a map transformation. So have a look at what I'm going to do. I'm going to apply the same logic to my RDD. So I'm going to create a new RDD called criminal records with month and type. And I say take crime data without header dot map, and I paste this whole thing. So you see, this is the effect of map transformation. The logic to extract the tuple you have written, but that will extract only from one line. I want to convert each line of my data to this format. So I call the map transformation, and within the map transformation, I type this entire logic, right? So what could have happened is that Spark could have created a new RDD called criminal records with month and type. Let's check out this RDD. And if I say dot take 5 dot for each println, very well. So now look at the data. The whole data is transformed into this. Now do you understand? Look at only battery. How many times battery is repeating in this thing? 3 times, right? I can easily do a word count program here, right? Because this will become my key, and 1 is the value. So if I want to know how many battery crimes happened in 2016 May, or any month for that matter, I do a simple reduce by key, I will get it. I hope you understand the logic behind that. And that is exactly what I'm going to do. I'm gonna create one more RDD. It's gonna be crime count per month per type. So I'm gonna say criminal records with month and type reduced by key. Instead of x comma y, I wrote total comma value, total plus value. So basically it does sort of like word count. So we will get a new RDD. And if I check this guy dot, let's say take 10, I know that this program looks a bit complicated, but you guys asked for me, right? You were crying yesterday, give me production program, give me production program. Now you suffer. Production programs are like this, nobody understand, right? People are like, okay, you are not showing better programs, you're always showing basic programs. Now, if you're not able to understand, I can't help. I can help little bit, but there is no other shortcut, right? You have to sit and read and understand. Production programs are like this only. It's not easy to interpret, it's not easy to understand. See, I can't do both, right? Either I can show you all simple programs, right? But if you say that, okay, I want to see a bit complicated program, the program will have a bit, logic into it, right? And not everybody will be able to catch it for the first time. So what I advise normally is that you take the data set, you take the solution, you break it down, step by step you run, you see what is happening. That is the only way to understand these kind of programs, right? Anyway, we have reached in a situation where now how the data looks like. So I will always tell my participants, before you write the code, you should see how the data looks like. So now the challenge is I have the data in sort of like a key value pair. Okay. And the key is a combination of what you say, the month and crime type. The value is how many crime happened in that month. For example, in 2012, April, 62 gambling crimes have happened. Or in 2004, July, 31 liquor law violations have happened. But now is the real challenge. The real challenge is now I have to sort this data based on month in ascending order. You see, it is not at all sorted. So my first challenge is I want to sort the data based on month in ascending order. At the same time, I want to sort based on number of crimes in descending order. Now, let me tell you one more thing. You may be thinking that it is easy. Okay, you do a sort by key, everything will work. Yeah, I understand. So if I try a sort by key, let me show you what will happen. I'm just going to say sort by key. Okay. Or probably we have to store it as something, right? So this is not part of the program. Sort by key. If I say a dot take 10 println, do you see what has happened? The data is sorted now because you can see that in 2012 January is there. These are all January crimes. Then February will come. But what is the problem now? Tell me. What is the problem now? I applied a sort by key. Did I get my final answer? Is this my final answer? If not, what is the problem here? Because the type of crime I want in December. So in 2012 January, I should first get assault, because not assault, battery, because most number of crime is battery. So this should come first. Then assault should come. Then probably criminal damage should come, right? But the problem with sort by key is that, so the problem with sort by key is that it's sorted based on your key. The key was what? The date and, then your, and also you see it is sorting alphabetically. Arson will come first, battery, A, B, C, D, G. So your key has two parts. There is a date and crime type. What it is doing in January, it is sorting based on A, B, C, D. Right? Now, even if you use sort by, this will not fix. Because the problem is here, when you say sort, you can sort either key or value or only one column. And that is my real problem. So if I say sort by key, it will sort based on this. Or I can say sort by value based on this. So one way I have to do it is that I can store this as an RDD. Again, I can pick up, the second part and sort it, but that will be very complicated. So I can solve this problem using sort by key again, but that logic is slightly complicated. I will explain that to you. We are going to use sort by key only for this problem. Let me see if I have given it somewhere, the explanation. Yeah, probably I will give you a fresh explanation. So let me pick up some data so I can explain it to you. Probably I will pick up, 4 lines of data. So let's say you are taking only these 4 lines of data. Okay, and the final output has to be in a different way, that, right? Now I'm going to use a logic to sort these guys. So this is my data, this is my original data after sorting, right? And you see it is like 2001, then it comes arson and 39, then it comes assault, then battery, then burglary. So no, I don't want it like this. I have written a logic. I will show you that. So we are trying to explore the final solution, right? So you see, I have written it here a little bit. The data looks like now you have a month column, and then there is a crime type like weapons violation, and then there is a count. This is how the data looks like, right? And what we are going to do is we are going to convert this into a different format. So we can, in fact, sort the data. So as an example, if you look at this code, right? So what I'm doing here is that I'm using sort by key for sure. I'm going to sort my data in sort by key. But like I said, if you simply do a sort by key, you will not get the desired output, right? So what I'm going to do here is I'm going to do a map transformation on the data. So let me just copy this whole thing so you'll understand what I'm doing. Yeah. So, sorry, solution, where is it? Right. So the original data looks like this now. So you have a key and a value, right? So in this data, what you need to understand is that, just put it like this. What is the key here? This is the key. And this is the value in our terms, or I would like to call it as a tuple, right? And what am I doing? I'm applying a map transformation. I'm saying that take every record. When I say every record, this whole thing is a record, okay? And I want to convert that into a specific format. Now this looks a bit confusing, but this is the format I want to convert it. So it says rec dot underscore one dot underscore one. So what do you really mean by this? When you say rec dot underscore one, it basically means the key. This is the whole key. Within that, again, you're saying dot underscore one, which basically means this part, right? So this is going to be the key. So let us write it so we can understand. So I'm going to take the first row of data. Okay. I'm going to take the first row of data, and rec dot underscore one is nothing but my key. Within that, again, dot underscore one is this part. I'm going to take this part, Control C, Control V. So this is this part, comma, negative value of rec dot underscore two. What is rec dot underscore two? That is nothing but this 39. Negative value of 39. Why? I will tell you. So I will convert this into negative, let's say 39. Okay. Then what I want to do, comma, so this comma, rec dot underscore one dot underscore one again comes here. So which is nothing but your 2012-01. And then I put a tab. So you see there is a tab here. And then what happens? You have rec dot underscore two. That is nothing but 39. This is 39. Again, I put a tab. Again, I say rec dot underscore one dot underscore two. That's nothing but arson in the first case. So my point is, this line is getting converted into this format. So what you need to understand about this format is that this is one part. It's like a key value pair. Then there is a tab. Then there is the crime number. Then there is a tab, and then there is arson. Right. So let me keep it separate so it's easy for us to read it. And also, I'll remove these commas and make it a more nicer to read it. Right. So this is one line. Similarly, all four lines will get converted. Right. So I think it is very similar. Right. So I can just do a copy paste. Control C, V, V, V. So this is going to be 2012. All are 01. Right. And the second one, the number is going to be what? 1294. Okay. And this is also going to be 1294. And the type is what? Assault. Okay. And the third one is going to be what? Negative 4307. Okay. And also going to be 4307. Okay. And this is what? Not arson. This is what? Battery. The last one is 1757. Okay, and here it is going to be 1757. And this is what kind of a crime? Burglary. So your original data, which was in this format, gets converted into this format. This is first thing you need to understand. Did you understand how did I convert it? It's very simple because you are just accessing the elements. I'm just saying that take every line of data and I need a key value pair like this, where the key is going to be the year, the value is going to be the negative count. I'll tell you why it is negative, comma, again I will put the year. Okay, so this whole thing is what you see here, this first part.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and data frame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
Then I put a tab and then I say, give me the second part of the data, that is the crime number 39. Then I'll say put a tab, again I need a tab, and give me the crime type, that is arson. So this data gets converted into this data. Now let me tell you why I did this negative number. There is a logic behind it. Okay, what is the logic? If you look at my solution, where is the solution? Yes. Can you tell me what will happen if I do a sort by key now on the above data, on this data set, Okay, by the way, in this data set, what is the key and what is the value? So this is going to be the key and this is going to be, these are just extra elements. These are not key or value or anything. This is what you need to concentrate. And this part is the key. This part is the value. If I do a sort by key, what is going to happen is that definitely it will start like January, February, March. The year will be sorted in ascending order. Within each year, what do you think will happen? These are negative numbers. So when you sort negative numbers in ascending order, is negative 39 bigger or 1294 bigger? What do you think? Which one is bigger? Negative 39 or negative 1294? Which one is bigger? 39 is bigger. 39 is bigger, right? When you talk about negative numbers, 39 is bigger and this is smaller and you are sorting in ascending order. So what will happen? Naturally, this line will come first. If you do a sort by key, this line will come first. Why this line is coming first? Because the smallest number here is negative 4307. Negative 4307. This is the key. You are touching only the key. Already you sorted based on January. Within January, you have 4 values and the lowest value is minus 4307. What will be the next candidate? Next candidate will be this guy because that is the next smallest one. What will be the next candidate? It will be this. What will be the next candidate? It will be this. Do you see what has happened now? What has really happened is that using the negative technique, you did ascending, descending sorting in the same piece of code, right? And now what I can do in the final output, I don't need the key. If you understood this much, what I can do is in the final output, I will say, I don't want the key. Yeah, I don't want the key. I was using the key for sorting. So if I copy paste this in the final output, okay, the key will be removed because you can omit to remove the key. And does this look like your expected output? Yes, it is. The year and month is sorted in ascending within each descending order for your crime type. I know it's a hard to understand, but this is what we are doing in the piece of code, right? So I used a negative number only for sorting so that I can retain the corresponding values. So when you sort, the remaining data also gets sorted, right? So when I say for negative 437, after a tab, I have a positive 4307, which is getting kept here. So naturally, the other part is getting sorted as well, right? So what we did, I'll just repeat once more, but I don't think even if I repeat, if you didn't catch it, you may understand. The only way to understand this is to run your code, right? I'll give you time to, I'll give you the answer. You can run the code and all, right? So I'll explain this once more. This is your original data. The original data gets converted in this format. And I think that part you have already understood, right? So now your data looks like this, right? And the data has a key, which is a combination of month and negative value of crime count. The value, again, that is a month, then a tab, crime count, and crime type. So that is how the data looks like now. And what I do, I run a sort by key on this data. So when I run a sort by key, since the key is a composite key, the key contains two parts, it's first gonna sort based on the month and year. So 2012, Jan, Feb, March, or 13, like that it'll come. Within 2012, it's gonna identify that there are 4 values. And sort by key, by default, since it does descending, it's gonna choose the smallest value first. So naturally, negative 4307 is going to come first. Automatically, since your data also contain the positive value, this guy will automatically become the first element here. And then 1715, 1294, 39. So your sort by key output is going to look like this. And then I can say, I want to avoid the key because the use of the key was only for sorting. I want the remaining data, you get the output. Now let's do this in the code as well, so you can understand. So where are we? Yeah, so we are here. Crime count per month per type. So the data is like this. Now the whole thing I wrote like a single line. There is no other way. But if I do this, you will understand. What I'm doing here is that I take the data. I will run a map transformation to extract the data in the format we have given. Then I do a sort by key. And after that, I will say I want only the second element. So I'm basically removing the key part from here. So now if you take the final RDD and do a take 10 and say for each println, see, now this is the expected final output. 2012 January, the most cases are theft, then battery, then narcotics. So you can see that the month is ascending and crime type is descending. Also the delimiter is tab. So this is the problem with certification questions. They want everything to be in the proper order. Now, if you think about the problem statement, you see how do you productionize a Spark program? So let me just delete some of these things. These might be required. So the next topic is how to productionize programs. Or in a very simple way, if you are a Spark developer, how do you write Spark programs? Will you actually take the Spark shell to develop this, right? For example, if you are a Spark developer working in a company, how do you write a Spark program? And how do you test it? Then how do you execute it? So the first thing that you need to understand is that if you are working as a Spark developer, one thing you can do is definitely you can look at the Spark shell. But that again is kind of like, I don't know. See, you have to type line by line and then see and So usually people prefer an IDE. So if you are a developer, and the first thing is that so let me write the things that you need to do. You have to download, let's say, IntelliJ. Now you can do this on Eclipse as well, but when it comes to Scala, IntelliJ is mostly preferred for Spark programs. So first step you need to do is that you have to download this IDE called IntelliJ. How do you download it? Very simple. You go to Google and just search for IntelliJ. You will land on the official website of IntelliJ, right? IntelliJ has a paid version and a free version. So if you click on the download link, it will show you the ultimate version and the community version. Ultimate version is the paid one. Don't download it. Community version is the free one. Just click on download. It will download, install it, and you will be having IntelliJ. Now I have already installed IntelliJ and I can show you that just to do this. Now, surprisingly, many of you will know this, but I see in every class, there will be some participants who are not aware of this. In order to run a Spark program, you don't have to install Spark. I don't know how many of you get this idea. So I am going to run a Spark program on my Windows laptop. Okay, I will run it and show you practically. I will run a Spark program end to end on my Windows laptop. And I will not install Spark. I don't need Spark at all. Well, Spark is required, but my point is you don't have to download and install Spark. Why? Because you need to use something called build tools. Now, see, if you're writing a Spark program, then you will be definitely using Spark libraries, right? So Spark has lot of libraries. So if you're looking at this Spark context, SC, they are all part of your Spark core library, right? So usually what we do is that we use something called a build tool. There is something called a build tool. So step number one is you download IntelliJ. Once you download, you start it. It will look something very similar to this. Step number two is download the build tool called SBT. There are many build tools. If you talk about them, there is something called Maven, there is Ant, there is Gradle, there is SBT. There are many build tools. What is the purpose of a build tool? A build tool can basically take a requirement from you. So I'm going to use something called SBT. I will download and install SBT on my Windows laptop. Okay. Once I download and install SBT on my Windows laptop, I can go to SBT and tell SBT that, you know, boss, I have a Spark program to compile. Okay, I need Spark libraries. This SBT will go to internet and download all the required libraries to compile my program. And it can do that for any open source project. So build tools are very popular. So for Spark programs, the most popular build tool is SBT or Maven, whatever you call it, right? So how do you install SBT? It's again very easy. You just go to Google, you say download SBT, and the first link is SBT download. It's pretty straightforward. You can see a .msi file for Windows. Click on it. It will download it. You will get a file. Next, SBT will be installed. I will show you how to build the program and all. Don't worry. Okay. But you need to download and install it. SBT actually stands for a Scala build tool. And it is not only for Spark. Any Scala project you can build using SBT. Spark is one of the frameworks which is written using Scala, right? There are many other frameworks. In all of them, SBT is a very popular build tool. So once you install SBT, SBT is a command line tool. There is no graphical user interface. There is no GUI or anything. So what you can do, you can open the command line, Windows command line, CMD, and just to check whether SBT is installed properly, you can type a command called SBT about. So there is a command called SBT about. If you run this command, let me run this. It will show you so many things. Don't worry. So it will show you so many things. Finally, it will show like this. This is SBT 0.13.16. So it is just showing you the version of SBT. I have a slightly older version. If you guys are downloading now, you may get a latest version. That's perfectly fine. But this is how you test whether SBT is properly installed. Just run the command SBT about. It should simply show you the version. That means everything is working fine. You're happy, right? Okay, so these are the prerequisites. You need to have IntelliJ, you need to have SBT. For Python, I don't know what is a build tool. Honestly, I don't know. I have never built a Python program, so I don't know. You need to check. There might be a build tool, or probably they are using some third-party tools. I never got an opportunity to build a Python program, right? Full name of SBT is Scala build tool. Scala build tool. Now the problem is you need some program, right? So once you download IntelliJ and then download and install SBT, you are ready to productionize your program. So naturally your question will be that how do I productionize my Spark program? So what do we do normally is that we will write a Spark program and test it locally. Spark can very well read from your Windows laptop or Linux or Mac or anything. So usually what I do is that if I have to develop a program, I'll take a sample data, copy to my C drive or D drive. I'll write everything inside IntelliJ. I'll read the data, write all the transformations, run it. I can even see the output on my IntelliJ. Right? Everything can be displayed in IntelliJ. So if everything works for me, I say, okay, everything is nice. What I will do, I'll just change the location of the data, compile it, and then run it in the Spark cluster. So end of the day, if you write a program, you have to compile and produce a jar file, jar file. In MapReduce, so MapReduce programs, I think you created a jar file, am I correct? You compiled it and created a jar file, right? And then that jar file you are running, correct? Yeah, very similar to that. Here also, you need to compile and create a jar file. Let me also show you the data. So I have written a simple program. If you look at the code, where is the data? I think it is in C data. So retail DB, order items. Yeah. So you are reading this file. See, there is a file called a part 00000. So this is nothing. This is basically some transaction data that we have. And let me also open the code and see what we are reading. So 1 and 4. So if you look at this data, this is the order ID. The second column is the order ID. Can you see? 1, 2. And the third and after that, the fourth and the fifth column is the amount. 299.98 is the amount. So if I look at the first line of data, the order is 1. Okay, that is the second value. And the amount is 299. If you look at the remaining 3 lines, what is order ID? 2. So under same order ID, there are 3 transactions. Okay, because in this line, the order ID is 2, amount is 199. Here, order ID is 2, amount is 50. Here, order ID is 2, amount is 99. So basically, you want to calculate total revenue per order ID. It's again like a word count program. So you will be taking this 2 as a key and this thing as a value, and then you do a reduce by key, you get the output. So I'm not really interested in the program. Rather than the program, I want to show you how to productionize it, right? So I have written a program. Now, when you write a Spark program, what are the things that you need to take care? First of all, who can tell me what is Spark context? Who can tell me? What is Spark context? Okay, Spark context is not the driver program. Okay, it's part of the driver program probably. It's part of the driver program. Let me ask you this question. In the Spark session, you have Spark context. Why do you need it? So the new way is Spark session, right? Even in Spark session, you get Spark context object. Why do you need it? So the answer is Spark context is the object which will communicate with your cluster manager like yarn, right? Spark context, remember the driver will communicate with cluster manager using Spark context object. So Spark context is not the driver, it's part of the driver. But when the driver want to talk to executors, driver want to talk to yarn, it uses this Spark context object. And normally what happens when you start the Spark shell, the Spark context will be available as SC. That is why you say sc.text file and all. So when you want to read something, you will say sc.text file, right? So if you are using a shell, the Spark shell, the Spark context object will be automatically created for you. But when you're developing a program, you need to create your own Spark context object. That is a rule. So in a shell, it will automatically appear. In a program, you need to create it. It's a class. You can basically call and instantiate. Basically, it is a class. You just create an object out of it. That is all you need to do. Also, you need to create something called Spark configuration object. What is this Spark configuration object? So I told you that if you're writing a Spark program, you can put all your configurations in the program. For example, whether my program should run in local mode or yarn mode. What is the name of my program? In what port number it should run? How many executors it need? How many processor cores it need? All these settings, okay, settings and configuration, you can add in the configuration object. And using the configuration object, you will initialize your Spark context object. So what the steps are like this. First, you create a Spark configuration object, and using the Spark configuration object, you initialize the Spark context object. This is what is going to happen. So when you write the program, I'll show you how this can be done. So you can import the Spark libraries, and all of this are available as libraries and classes. You just need to say new for creating an object out of a class. So first you will create a Spark configuration object, add some properties to that, and using the Spark configuration object, you will initialize your Spark context object. Once you have the Spark context object, remaining code is same as you know. If you observe a MapReduce program, it is also very similar. I don't know how many of you have seen a MapReduce program. In the MapReduce program, in the driver part of the code, you will create a conf variable, configuration, right? And under that conf variable, you will call the mapper class, reducer class, everything. So the idea is same, but we have to manually create these things inside our Spark program. That is the prerequisite. Once you create your Spark context object inside the program, then you can read the data, write it. Now, like Monangi was rightly pointing out, there is another thing called Spark session. Spark session is the new way of accessing, it is a new entry point to Spark's functionality. There is something called Spark session object. We will talk about that more in the Spark SQL class. But in the modern programs or the latest programs, when you look at the program, they will create something called Spark session and then initialize Spark context from the Spark session. Either way, you can do it. It's up to you. Without Spark context object, nothing will work basically in Spark, because that is the object for communication, right? So driver and executors, driver and cluster manager, they talk using this object.
Now let us look at the career opportunities in Spark. So isn't Spark doing a great job? Also, it is a fact that Apache Spark developers are among the highest paid programmers in the Hadoop framework as compared to 10 other Hadoop development tools. As per a recent survey by O'Reilly Media, it was evident that having Apache Spark skills under your belt can give you a hike in salary, and also mastering Scala programming can give you a further jump in your annual salary. This is the best time to start your career in Spark.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below.